Good morning. My name is Josh Gottheimer. I'm a senior counselor to Chairman Janikowski at the FCC, and I just want to thank each of you for being with us this morning. We appreciate you taking the time to be with us to talk about the development of the FCC's Cybersecurity Roadmap. This is a very important priority to us, and I just want you to know how much we appreciate you being here today. I particularly want to thank our panelists and welcome them. Ed Amoroso, Drew Dale, Jim Lewis, Andy Ellis, Andy Ogilsky, Rodney Jaffe, Bill McGinnis, Michael Reardon, and Ari Schwartz. And I want to thank each of them for taking time from their demanding schedules to be here. I know how busy each of you are, and it means quite a bit to us that you took the time. They all bring us a wealth of expertise, and we are fortunate to have them here to assist us with this most important endeavor, the security of our nation's public cyberspace and its underlying communications infrastructure. It's critical to our country's security and very, very important, again, to what we do here at the FCC. The public internet, like other critical infrastructures, is under constant assault, as you all know, by malicious traffic and is known to harbor a number of potentially disabling vulnerabilities, weaknesses that could adversely affect both corporations and individuals alike. According to a recent GAO study, the direct economic impact for cybercrime is in the billions of dollars annually. In 2005, which is not that long ago, the FBI estimated the annual loss due to computer crime to be more than $67 billion for U.S. organizations. With attacks dramatically increasing every single day, we can only imagine what that number has climbed to today. We've been working very hard here at the FCC to identify 5 of the most critical cybersecurity threats to the communications infrastructure and its end users, and to develop a plan of attack to address those threats. During the workshop that we have here today, we will have panel discussions exploring cybersecurity issues, including secure routing and directory services, and a panel identifying the key security vulnerabilities from an end user's perspective. We will discuss ways to increase awareness of communications reliability and security, incentives for ISPs to implement network security practices, protocols, and technologies. We will also consider what should be done to help consumers deal with cybersecurity threats and incidents. I think this is an issue that's on the top of everyone's mind in our country, and not just the people here in this room, and the fact that we are bringing some of these experts together to find solutions and to talk about them is critical, and I think we're all as a country are going to learn a lot from what we hear today. Because together we believe strongly that an effective cybersecurity strategy must include a collaboration and partnership between the public and private sectors. We certainly don't have all the answers here at the FCC, and I know that you all are going to be very, very important in bringing and enlightening what we do know. To that end, we are eager to hear more about your ideas on this important issue. We are confident that working together, we can make substantial progress toward making our nation and our world a safer place. So thank you again for being here. Again, we appreciate it, and I'd now like to turn the podium over to Jeff Goldthorpe, who's our Associate Chief for Cybersecurity and Communications Reliability, who'll be serving as your moderator today, and I can tell you has the Chairman's full confidence of someone who's on the front lines and understands this issue, and there are a few people in the country right now who understand it like Jeff does. So Jeff, thank you very much for taking your time today.
Thanks, Josh. Welcome to our panelists for both panels today. And let me spend just a minute to put this all in context for folks. And thank you all for coming, and thanks to our audience on the web as well. We have 2 panels this morning to cover these topics. The first panel is going to be dealing with threats and vulnerabilities that affect core communications infrastructures. And the second panel is going to be dealing with threats and vulnerabilities that are closer to the edge of the network, that affect customers of all kinds, enterprise customers, consumers, the kinds of things that we in our daily lives encounter and deal with when we think about cybersecurity. But a lot of those things have their roots in the kind of vulnerabilities that we'll be talking about in the first panel this morning. I've had a chance to meet with just about all of the folks on the panel today. We do have one change or one switch. Rodney Jaffe will be on the first panel this morning, and Jim Lewis will be on the second panel that follows. So that's just a change that we've made very recently. So with that, the way we'll do the panel today, we'll just do very quick introductions of each of the panelists, and then I've got a set of questions that I'd like to go through with folks, and we'll just have a dialogue to talk about it. So Ed, why don't we start with you?
Okay, I'm Ed Amorosa, 25-year career at AT&T, charged with protecting infrastructure and running our managed and network-based security services. And nice to see you all.
My name is Dale Drew. I've got responsibility for global security at Level 3 Communications.
My name is Andy Ellis. I'm the Director of Information Security and Chief Security Architect for Akamai Technologies.
And I'm Rodney Jaffe. I'm Senior Vice President, Senior Technologist at Neustar, and I head our security practice.
And I'm Andy Ogielski, President and founder of Renesys, Internet Analytics and Cybersecurity Company.
Okay, thank you all again. There will be, by the way, time for questions from the audience, and we'll also have questions that come in over the wire, so to speak. So, and I'll hold those. I'll have time at the end to go through questions. So please be thinking of those as we talk today. There's several topics that come to my mind or come to our minds when we think about vulnerabilities and threats in the core of the internet. And the first is routing protocols and routing infrastructure. The internet, as most of you know, is a network of networks. It's dynamic. It changes organically. It was designed that way years and years ago, so that if there's a disruption to infrastructure in the internet itself, the internet's able to route around that, at least to a point. As new networks are added to the internet, they're added dynamically. So the provisioning task there is much less cumbersome than in networks in previous years. So the protocol that enables all of that to happen, that organic aspect of the internet, is the Border Gateway Protocol. I'm not going to be talking too technical today, but I will use that term, Border Gateway Protocol, or BGP, because we know, and it's been known for some time, that there are vulnerabilities in the Border Gateway BGP. Let's just start with that. BGP. There are vulnerabilities in BGP that have been there for some time, and there have been solutions that have been known for some time. Maybe somewhat difficult to implement, but as time has gone by, solutions have come about that are maybe easier to implement. And I'd like to talk to folks on the panel today about BGP, standard long-term solutions to the vulnerabilities that exist in BGP, as well as workarounds that can be applied while we wait for a longer-term solution. And the first question is how long do you all think we have to wait before standards for secure or for a secure BGP, regardless of what it's called, because I know the original solution that was proposed was secure BGP. The ultimate solution may not be called that, but secure routing protocols, how long do you all think? Anybody want to hazard a guess?
Well, I think it only took us, 15 years to get secure DNS, and that's only barely rolling out now. So I think we may be in for a long wait there. I think one of the things we should be cognizant of is BGP has more defects than just the vulnerabilities that we talk about. Right? When we consider the critical nature of BGP, it fails more often due to catastrophic occurrences, an earthquake or a cable cut, because it's not capable of adapting to congestion in what we would consider real time. We should remember that BGP was designed to be survivable in an era where we worried about being able to deliver email within 4 days, not in an era where people expect a web page to download within 2 seconds. So it doesn't necessarily have the robustness that you might expect for a real-time protocol. So even as we're looking at a secure BGP, which often is designed for dealing with adversaries who might try to steal routes, we should be cognizant that it has other defects as well that we should be thinking about and working to mitigate.
Yeah, I have a comment as well. Whenever any of us come to visit here in Washington and talk about security initiatives around existing infrastructure, it seems like 9 times out of 10 it's some sort of a public key infrastructure overlay. Right? That seems to be the solution of preference for almost anything, DNS, BGP, you name it. And while there's no question that hardening the authenticity of announcements and advertisements and responses to message queries. It's a good idea, good computer science. We measure PKI in like units of decade, right? I mean, so as operators, we know that the complexity associated with overlaying, these key infrastructure programs is enormous. And the reason you have not seen these things roll out is because all of us have kind of weighed the pros and cons and determined that it's really hard to do, and it's unclear what the real benefit is. There's certainly some security benefit. And in contrast, you look at some of the e-commerce protocols like SSL embedded in the browser. That rolled out immediately because it made sense. The end user doesn't have to do anything. There's a great financial model. It just made sense, and boom, essentially global PKI-based e-commerce is ubiquitous because the pros and cons played nicely. I just worry that for both BGP and DNS, it's just sort of a natural selection. The reason it hasn't rolled out is because that pro-con sort of decision is certainly not obvious to me. So I would say, who knows in terms of time.
Yeah, just one thought on that as well in terms of BGP and some kind of overlay for security. One of the problems that you're going to run into is the same thing that we face in the DNS world. As you know, the current versions of Bind are capable of DNSSEC. There are still systems out there that use Bind 4.9, which was deprecated in 1999. So when you start to look at implementing a protocol in BGP, the thing you have to realize is that there are millions of routers out there, and the chances of all of those routers having the protocol implemented are pretty close to zero, certainly in the next 10 years. Just the life cycle of some of the routers is longer than that. So I think that it may be a solution for the core, but until you can actually authenticate and secure all the way to the edge, it's not going to be that useful because that's where a lot of the attacks come from.
And you're talking, when you say secure and authenticate all the way out to the edge, you're talking DNSSEC or BGP?
Now I'm talking about routers, BGP.
Okay.
In order to have routers, one of the problems we have is, which has been visible in some of the incidents we've seen this year, is that there is no single authority for routes. So it's possible for anyone to either originate or insert themselves in a route, and there's no mechanism for knowing whether they should be in the path or not because of the dynamic nature of routing that you already described, the benefit of BGP. So there are a lot of challenges, but that BGP-SEC or RPKI, which is what we're looking at now, the chances of that being useful all the way to the end if there's got to be a change in the protocol, just because of the costs of upgrading, are pretty significant.
I would like to call attention to a different property that's critical. BGP is fairly unique among internet protocols in that it has two components: the technical component for propagation of routes between border routers, and the business component for which routes are actually selected. Both parts of BGP can be subject to security threats or abuses. As far as I know, none of the research proposals addresses the route selection component. And just selecting the delivery of routes, or the authentication of routes, does not solve the problem at all. So that's one comment. The second comment is that there is ongoing research in academia on next generation routing protocols. The issue is that BGP is not only insecure, it's also an unstable protocol in principle. So routes do not have any guarantees of converging. Internet is large. We have about 330,000 routes currently in the global routing tables. But with IPv6, we are shooting for perhaps several 100,000 or several million routes rather quickly. So I would say that from the perspective of national security and good service to end customers, we should also think about stabilizing global routing protocols and improving its convergence properties.
Okay. All right. Thank you. I've heard a couple of things. I've heard, first of all, I think just about everybody says it's going to take a long time. It's going to take a long time before there's a standard implementable when I say implementable, I mean cost-effective. There's a business case that the end justifies the means, so to speak. Implementable, long-term solution. So it'll be a long time, and that there's not a clear benefit that justifies the expense and the complexity of doing it. I've also heard, and this I'll try and get into when we get into reliability and resiliency. I've also heard that there are issues with BGP that touch on resiliency more than the kind of customary vulnerabilities that you hear about. So so when we talk about route stability and so forth, I think that's something we'll try and touch on when we get to resiliency. And that'll be coming up. But if we then assume that it's going to be some time before we have a standard, implementable, secure solution for BGP that's being deployed on a wholesale basis, sort of like what's happening with DNSSEC now, all right? Then the next question is there a way in the meantime that operational best practices can be applied effectively to compensate for vulnerabilities? I think this is happening now, but I just want to toss it out there as a question. Is that an effective way to deal with the vulnerabilities that we know are there while we're waiting for something that can be a longer-term solution?
Yes, I would say. I mean, the filtering of customer routes at the edge goes very long way.
Could you repeat that, Andy? I didn't hear.
Filtering of customer routes at the edge. Essentially, if I am a carrier or network service provider, and I take on a new BGP customer, meaning customer who will route using the BGP protocol to me, I can reasonably easily assure that the only routes I accept from this customer are the ones to networks that this customer actually owns and operates. In other words, that there is no identity theft going on. This way I can scale the problem pretty well because I go to the edge. Once routes traverse the edge, they have phenomenal mechanisms of spreading worldwide, no matter what you do. So the edge protection is definitely the first step.
Yeah, I would echo that in a slightly different way, which is I agree with what the panelists have said with regards to the biggest challenge being the implementation of a PKI to make this successful. The age of the infrastructure in performing crypto functions is also a very large concern. But as far as what do we do in the meantime, I would say that the implementation of a global route registry to understand which ASs own what networks and to ensure that we can implement route filters based on that route registry is going to be a stopgap between now and the time that we have those PKI issues solved.
I mean, there's a historical component to this. When we were doing stuff in the 90s, that's the way that it worked. They were routing registries, and you knew what routes you would be expecting from your peers. And over the last 10 years, that's to a large extent disappeared. What we deal now are numbers of routes. So when we peer with another network, they won't give us the list of routes necessarily. They'll give us the number of routes, and if it goes too far beyond that, there'll be an interruption, and we'll talk to each other and update it. We have to get back to the kind of control we had in the beginning when it was easier in order to authenticate the origin of those routes. However, one of the problems is that in the modern world, you almost can't easily control how people change their connectivity. It's possible today to be able to bring up a circuit with a new provider within 24 hours. It used to take 90 days. So there was time to register routes. Now it's much more dynamic. So we're going to have to find a way of making that much more usable, given the number of routes out there and the way that people change connectivity on a daily basis.
Is that why over the years we've drifted away from this practice that seemed to be effective some time ago, and now we're in the mode of just getting the number of routes instead of the identity?
The overhead and the systems required to keep track of the changes just didn't keep pace with the number of changes that we've had. The internet, I mean, we've outgrown the systems that we had in place.
So what would need to be done to overcome that, to get back? What are some specific things that would need to happen to get us back to a practice of some years ago where we could at least effectively overcome some of the vulnerabilities that exist? And in particular, towards a global route registry?
I think first you're going to need to have people who want to consume the global route registry, right? If we went and told all of the networks that they're responsible for providing the data and there's nobody consuming the data, then they have really no valid business interest in providing it. But if they want to consume it as well, right, you begin to have a market for that data effectively. And here's, I think, one place we can look at DNSSEC, which has its failures for having taken so long, but when we look at why people are deploying DNSSEC today, has everything to do with a market for DNSSEC, right? The government is buying DNSSEC, wants everybody using DNSSEC, and rather than mandating it, is instead buying it. That's incentivized everybody to build the capabilities, bring them to market, and then can turn and resell those capabilities elsewhere. So possibly learning from what worked for DNSSEC and having the government consuming this and potentially paying for it and providing it might be a good place for us to investigate how to change the dynamic today.
I would add also that good quality routing contributes towards consumer protection. So if you are in a business of assuring certain quality of service, then a provider who is really sloppy and whose routing does not cover big parts of the world from time to time may not satisfy, say, your requirements for what constitutes good quality of service.
So a lot of good practical suggestions, clearly. Another dimension that hasn't been mentioned is the R&D component, research. So certainly from a government perspective, you're asking what can be done. R&D in this area has been maybe a bit thin, I think. I know in our lab we've got a number of programs where we build these service control points using route reflectors to almost build an SS7-like component for routing. It has its usefulness as we steer traffic around for like denial of service and so on. But the point is that maybe one of the things to include on the list here would be some reinvigoration around funding in this area for R&D activity, incenting different types of research groups to dig in at more than just, say, a superficial level. And I'm guessing that most of us would be very happy to collaborate and make use of the research. So I'd add that to the list as well.
Okay. I want to stay on this the topic of how best practices, operational best practices can be. We've talked about the idea of a global route registry, and one thing that occurred to me, and I want to stay on that for just a second before we talk broader about how operations methods and procedures and so forth can deal with some of these things. But a global route registry, we've talked about some of the things that would be done to get something like that, make it come into being. But are there issues, obstacles, concerns about a global route registry, that it would somehow it is not in keeping with the sort of spirit of the, is this one of the things that when I hear about BGP and I hear about solutions to BGP, to vulnerabilities in BGP, I hear that sort of thing, that this is sort of anti-internet, so to speak. Is this making any sense, or is it?
I would like just to clarify.
Yeah.
There are really two things, Jeff. Ownership of IP net blocks,
yeah,
which can be registered and should be registered, and registering of routing policies, which people object to, and it's very complex.
Mm-hmm.
That's one of the key differences between DNS and BGP. That in DNS you just certify a very simple directory relationship. In routing, the routing object is really very complex. It has a lot of attributes.
Mm-hmm.
So which registry do you have in mind?
Well, I want to get back. Let me get back to the original point, which was that when we first started talking about how best practices could deal with could help us get through this time between now and when we've got a longer-term solution to the problems at hand. One of the solutions that was teed up was the idea of a global route registry. So, what I'm talking about is what I think Andy had in mind when he suggested that.
Right, and that's the directory service versus the business logic directory.
Right.
And I think that some of the hesitance that people have had really ties to how easy it is for you to make changes. You know, as was just brought up, people can very easily switch providers, have new routes up within 24 hours. If we have a registry that is controlled by what's perceived to be a central authority or a cartel of authorities, such that people can't easily move, right? That becomes a worry that, you know, I think folks have. I think it's an overblown worry, but I think it's something that we must remain cognizant of and be sure that a registry is designed to be a peer-based community rather than a top-down community.
Does anybody have any suggestions or recommendations for how that would be administered? How it could be brought into being in such a way that people would buy into it, just from a policy standpoint?
Well, one of the problems you've got to realize is that this is not a U.S.-centric issue. It's a global issue, and you're dealing with 200 or something like 200 different countries, but you're dealing with corporations and organizations that are not governments. So this is something that really is going to have to be driven by a business need rather than a political or legislative process, because legislatively it's not going to happen.
Is there a business need?
There's definitely a business need. I think that's what we're all discussing now, is that, you know, there are issues with it and some of them will be solved. But you're going to have to provide a solution that's cost effective and that also meets the needs of the smaller users, those people who do want to switch providers. Otherwise you start to get into the problem of a premium having to be paid in order to make a move. And that's the thing we don't want to have happen.
And that's a cornerstone of attribution too. Who operates which IP address?
What else when it comes to best practices in this area? Any ideas about what could be done between now and Nirvana?
Well, I think one of the things we have to do is validate what Rodney just said, because I actually don't necessarily agree that there's a business need. Right? Or at least there's certainly not a perceived business need. If there were, people would be doing something. Right? And part of the problem here is, as with most information security risks, risk is so diffuse within the environment that most people perceive that the risk doesn't really impact them. Right? So if I have a risk that a meteor is going to hit my building, you know, it's very small, very unlikely to happen, but if it happens, I'm out of business. How many people actually plan for meteor strikes on their buildings, right? Because it's perceived to be such a small risk. BGP theft suffers from that same perception, right? Most people look at it and say, well, my routes have never been hijacked or stolen, or when they were stolen, it didn't actually cost me much money, so they don't perceive that there's an actual loss potential for them. Right? So one thing we should do is validate whether there is a business need and whether it's just not well understood, and see if we can get the market moving to solving that business need.
I think Andy's right. I totally agree. One of the things that should be recognized is that routing in the context of security sometimes is part of the active defense, right? When you're in the midst of a denial of service attack, there's multiple providers involved. Sometimes you're using routing to slosh traffic around. And I incent my team to get better and faster and quicker around that sort of thing. And when we keep saying there are these pros and cons to these different initiatives, at a very high level, you can think about these types of proposals as either being somewhat slower, more controlled, more centralized, more governed, versus really fast and nimble and quick and agile. And I'm just saying that I think there's security benefits in both areas. And I know when I bring up the idea of these global registries to my own team, a lot of times they come right back to me with some of the points that Andy was making, that, yeah, well, if we had that, then how do we do this, that, and the other thing that you're asking us to do more quickly and more nimbly? So there really are valid reasons to question the idea of a central authority. Again, you can get on either side of this, and you can make the case depending on your context. So I think it's important to keep that in mind.
One comment I'd make is that you know, let's be clear that as communications providers, we are very quick to respond to security threats, to threats against the reliability and the stability of the network. So when there were BGP protocol threats, as a community, we did respond pretty well. We implemented, I think, what we collectively thought was a good enough solution. when we try to carry that argument to a more complete solution, we get in the argument of PKI, and we get in the argument of old infrastructure not being able to handle the crypto function. So, I mean, there is a business driver in the sense that we all want to operate very reliable backbone networks. We are seeing a lot of activity in this space of protocol disruption. And like I said, I believe we all responded pretty quickly to those threats as a community to come up with a common approach to it. The issue is that we either need to develop into the mind share from a research and development perspective of either solving the PKI problem or solving the global route registry problem.
I want to spend a minute on what Ed was describing a second ago, which are the things that make operators nimble, right? So we've talked about sort of interim solutions that are more, I'll say, in a sense, are perceived to be top-heavy, right, and somewhat cumbersome. And that's not a judgment, that's just an observation. And others that are where you've got individual operators that have ways of dealing day to day with things that are happening on their networks, and by way of route hijacks and so forth. And so another way of coming at this is, instead of top-down, look at it bottom up and saying, is there a way, or is there a collection or a set of such operational, when I say operational now, I'm talking nimble, best practices that are applied by ISPs, carriers, to deal with, to run their networks day to day, that should be assembled in a way that that industry at large can learn and benefit from that.
I mean, I can offer a thought here, and in some sense it goes a little bit around what you're saying. Let me give an analogy. When your house is on fire, you tend not to worry too much about floods. And I think, Dale and I were talking a moment ago, there are these insidious problems right now across the internet that are rooted in botnets and malware. And again, Dale and I were chatting. My team is spending most of its time worrying about that. And a lot of these issues around infrastructure, they're nonetheless valid. But right now, my team is obsessed with problems around botnets, which actually rely on our infrastructure working properly. So we've sensed that the threat has shifted somewhat. We've seen less attacks, say, on the internet or at us, and more using us to go after financial gain. So the threat that seemed so real 2 or 3 years ago around attacks at infrastructure really in 2 years has changed.
What about attacks that are directed at exploiting vulnerabilities in infrastructure to carry out attacks across your...
There's no question that they haven't disappeared, but I'm just saying that the preponderance of, say, this new term, this advanced persistent threat, right, that we talk about, is so intense that I know with my team I've probably shifted 75 to 80% of my resources toward that problem because it's become so intense. So again, I don't mean to derail the question, because I think you're right. You're asking about best practice. I know that's what we all do for a living. It's our job to create and follow and run best practices. And what I've found, having been doing this my whole life, for 25 years of nothing but this, is that it's hard to lay out a concrete set of best practices and follow it, because what we do is so fluid that we have to be willing to take the playbook and throw it out and start a new one, the next week or the next month, depending on what the threat is. And I know that right now I sort of wander around all day thinking about and being obsessed with the problem of how botnets are affecting our customers and affecting all your PCs. Half the people in this room probably have a keystroke logger on their PC that's collecting all of their their credential information, and I think, I don't know about you guys, but I'm like obsessed with that and worried about how we solve it. And the attackers who go after that would just as soon see the naming and routing work perfectly fine. I mean, they certainly exploit that with with controllers and so on. But so I just offer that as a point around best practice, that our best practices shift and they change and they follow the threat. I wish they would precede the threat, but too often they follow it. So for me, I'm not sure I can give you a good answer from my perspective that I can say here are the 4 or 5 things that we should write down and industry should learn from us, because I know in my group we're changing so often. I don't know how the others feel about that.
Yes, let me just restate.
Hope that was useful.
Yeah, no, it is, and I think I want to restate the question just a little bit. I'm not looking necessarily for specific instances of what is being done by folks today. I mean, that's of interest. I think, though, that right now the more interesting question is it constructive or to talk about for there to be a set of practices that where folks are learning from each other. We've done this in the past, right? And I understand that the threats are different now than they were years ago. But with groups like, say, NRIC, and there are other public-private venues around where best practices have been created to deal with reliability issues and resiliency issues and so forth. Things that don't change as quickly, right? The attack vectors, or however you want to describe that doesn't change as quickly as what we're talking about here. But still, there's been a perceived value in having industry collaborate, get together, and share ideas on how they operate today, knowing that could change tomorrow, and that these are not things that have to be done, that different circumstances may call for different methods. But that it's certainly useful, given that we don't have a standard long-term solution to BGP vulnerabilities. Is there a set of operational best practices that could be composed, or do they already exist? Does IETF, have they created this, right? Or
I mean, I would say that I think the problem that we have right now in this particular space. I mean, I would agree, by the way, from a focus perspective. I think as a community we're very good at putting enough fingers in the dam to solve the problem so we can move on to the next firefight. I think in the space of BGP security, we're kind of being overwhelmed with the number of proposals and standards right now to identify which is the best practice we all want to follow. So I think that it's my belief that as internet providers, we're as adaptive as we need to be to solve for the threat, to make sure the networks are reliable, and I think that the weakness that we have is that we tend to focus our attention on the next firefight, whereas in this particular space, I'm going to say this again, there's a lot of work that has to be done on how to solve the PKI problem, so that way as these protocol attacks evolve, or as more infrastructures become dependent upon a PKI. We can have that at the ready. But right now, as Ed mentioned, I have the same issue where we're seeing a definite shift in focus where it's no longer an attack against a server; it's an attack against a person who operates a server. So we're seeing botnet attacks being very, very focused on the engineers who operate the infrastructure to get access to the command plane, as opposed to trying to attack specific servers. So it's a huge focus area for us as well.
I think we can sort of formalize what Ed just brought out and some of what Dale said. Right, the strength of the internet, and when I say the internet here, I actually am referring to the people and the organizations as well as the systems, has always been its flexibility. Right? And people rapidly respond. They don't require central coordination necessarily to do so. Right? We each deal with problems in our own infrastructure or problems where we see a business opportunity, and that works very well. Right? There's certainly a place for us to improve how we bring new people into that internet community. Right? And that's where a lot of the best practice sharing does really great work. One of the challenges we run into is an imposition of a centralized command and control infrastructure. Right? Somebody learns, oh, there's a threat targeting over here, so I'm going to call such and such an entity. But I fail to call the 5 other entities that might have been involved or might have been able to help. So I think one of the things we need to do is be better about building bridges among all of the members of the community, and not just those of us who happen to have names of corporations that people might recognize and invite us to say, oh, why don't you 3 go join but there's thousands of other entities out there that can participate. And what's important for all of us is to have those communication lines open so that in an emergency we can rapidly reach out to our peers to make changes. I think where there is a great place for central coordination is really on the detection of problem side, right? To be able to respond to a problem, you have to know there's a problem. And quite often the entities involved in the problem aren't the ones directly impacted, so they don't necessarily even know there's a problem, right? They're impacting someone else. If one of Ed's customers is stealing routes for one of Dale's customers, Dale's the one who knows there's a problem, not Ed, until Dale picks up the phone and calls Ed. And somebody has to have told, and noticed that there was a problem. So I think that's an area that we can look at an investment in better detection of adversarial action against the internet infrastructure itself.
Let's turn now to a slightly different topic, and that's measurement. And in particular, what sorts of, I'll use the term performance metrics or measures should be used to measure the extent to which the problems associated with route hijacks and so forth are getting better or worse? I mean, how would you suggest that be measured? And what sort of measurement infrastructure is needed in order to arrive at those sorts of measures?
Well, maybe I'll start because that's what we are doing. The measurement infrastructure exists both in academic environments. There is a research routing measurement infrastructure, University of Oregon, RIPE, as well as commercially. Several companies, Akamai, for instance, has been involved in this. We are involved in this. So I would say that we have very good insight into the operation of the global routing system to the extent that we can run real-time alerts on unexpected route changes for the entire world all the time. So one sees what happens. It's by design of the protocol itself, which is very different from telephony. What one does with this, that's a different story, and there were statements from my colleagues here that that's a business issue. So I would be actually curious to hear from the operators.
Well, it's
So
hard.
suppose you
It's a-
know,
it's a
what do
hard
you do with
problem.
it?
I mean, again, I don't know how many of you are familiar with sort of the basics of how these things work, but we've tried to build tools. Like think of it as like tools that would go around the globe and try and look to see what you look like all the time, right? Not from your vantage point, but from several different vantage points. Trying to build those types. It turns out that's not that easy a thing to do, right? So for us, when you say metrics and measurement, I think R&D, because I mean, at a real practical level, the metrics and measurements come right down to your interaction with your customers. Like that's what we measure at the most basic level. Do we have problems with customers? If we don't, if there are care centers and call centers and everybody seems to be pretty happy and the life cycle teams are happy, generally there's perception that there's no problem, but we recognize that you need to go a little further. But as I said, when you say identifying good metrics, for us, we have a number of research tools that we try. We run them, we see if they work, we see if they help, and I would characterize at least what we've built as being not all that useful or accurate. Generally when there's problems, I find out about them in any number of ad hoc ways today. I don't know if you guys do better than that.
So I think, sort of to both gentlemen's points, being able to detect something like there's an unexpected route change is easy if you have a very sloppy definition of unexpected. I didn't expect that route change, but the person who put it in probably did. And there's an awful lot of those that happen all the time. That sort of goes to Ed's point that if you try to look at what a given entity looks like from around the internet, it's very hard to actually say whether that's an appropriate measure. And I think we've often focused on simply measuring that. Looking at that globally, that's a very useful metric of internet health. Right? If there's an awful lot of unexpected route updates, that's very interesting information for me. Right? But that doesn't necessarily say that one person has been targeted. And I think to Ed's point of, we have to be able to measure the business impact of adversarial action. So if somebody stole my route, what did that cost me? And I think today we're very bad at actually measuring real costs of attacks on internet infrastructure.
Rod?
I'm sort of not, I'm not going to particularly agree with what you're saying, because what you're talking about is something different, which is the stability of the internet at large. But if you start to think in terms of security, which is what we're talking about now, all it needs is for one route, the wrong route, to have been modified to cause catastrophic damage in many ways. And we don't yet know which of those routes are. In fact, there'll probably be routes forever that we don't know are that critical. It's just the nature of the world. This is, the entire world, not a single system. And it's a real issue. We can look at route stability, and that's the kind of thing that Andy's company does very well, and Akamai is obviously very aware of. But at the end of the day, it depends on what problem you're trying to actually deal with and solve. If you're talking about the stability of the internet in general, it's pretty stable. People tend to get where they want to go in general. We've just had a disruption in the last couple of days, as you know, with Myanmar, with a country that was affected. Pretty much everyone knew when it happened. But the problem is that you can sometimes have a single event, a single route that people don't notice. We had that with the iRoot server, as you know, in March. It was undetected for anywhere between hours and days. But the effects could have been quite catastrophic. And I think what we have to think about is the problem we're actually trying to discuss or solve over here. When you talk about measurements, as Edith said earlier, I think, Andy, you don't know what you don't know. You don't know that person A actually intended that to happen. It may have been for a good reason or a bad reason, but we'll never know that. So if we're trying to build a system that's going to assume that we know what everyone's intent is, it's just not going to happen. There's no way of measuring that. And I don't know that there'll ever be a system where people can actually put their own, if you're looking for a system that has gives everyone the ability to put their policy into it, that'll just never scale. It won't work.
No, what I'm looking for instead is a metric that could be applied to know over the course of time whether or not the problems we're talking about here are getting better or worse. And I understand that that has to be weighted somehow according to some factor, that whether it's business impact or national security impact or some other.
Would you say that we have a measure or a metric for whether, say, the virus problem has gotten better or worse since 2005?
I've seen publicly available data like that from.
Because I would say sources. It's just changed. Mm-hmm. Like, I don't know that it's gotten better or worse. It's just different, Mm-hmm. And most of the people in this room would say, yeah, of course it's gotten better. In 2003, 2004, 2005, we had Blaster, Slammer, Nachi, Sasser, all this stuff. And I come in the morning and didn't know whether the LAN was going to be working, or whether I had to go, take my PC to the cafeteria and have it cleaned or something. So you'd say, well, obviously it's gotten better. But most of us would say, it really hasn't gotten better. Maybe in some sense it's gotten worse. It's just different, right? Well, yeah, and that's why I think it's hard to say, let's build, because I do the same thing. I'm a manager and I demand from my team, all right, I want to see a curve that looks like this, that has an X and a Y axis, that starts with all this problems, real high on the Y axis, and just getting started, so along this way. And then I want to see it come down and say, wow, it's really good computer security. We did this. Like with DLP, sometimes you do that. You measure, here's all the credit card numbers I see through the gateway. Then I put a DLP system in, and I yell at everybody. And I put on auto notification. Then I put on mandatory block. And you got a great curve, and it plays nicely. CEO loves it. You say, look, made an investment. We used to have this big problem up here, and I got this little problem down here. Man, that's good. And give me a big bonus, because look what I did. Yeah. So I completely concur that that's kind of what you try to build in computer security. But for a lot of these kinds of things, particularly routing and naming, I don't know that you could. For me, it's this elusive sort of changing thing that we're chasing after. Like, we came up with a global route registry. Is there any doubt on here we'd be talking about, clever hacks on that, right? We'd be talking about, you can either put all your eggs in one basket, or you can there are all these different scenarios, we might make things worse with a route registry. I don't know. I'm just saying that the one axiom I absolutely guarantee, and the way I would recommend that we think about the problem is not as a, how can we get our arms around this problem and do a bunch of things to make it better, but rather to recognize that there's a changing nature in all the threats we deal with, and to make sure that we are up to the task of dealing with that changing threat from now until forever, as long as we have communications networks. That may be somewhat depressing, but it's also exciting. I mean, that's what we love about the internet, that it's changing thing. We haven't even talked about mobility, right? I mean, as you get into a wireless world, what does that mean for routes and naming? Pretty fundamentally different game when people are using mobile devices to hit cloud assets versus all these little hunkered down, companies that are buying from Akamai and Level 3 and others. It's a different architecture, right? So the threats are going to change. So I just recommend that think about the problem that way. And again, I'm a manager. I know where you're coming from. But for something like this, I don't think you're ever going to get a metric that says we've gone from this level of problem for routing, we did all this stuff, and now we're at this level. I'm not convinced that that's the right way to think about the problem.
Let me say something before.
Either.
Sorry?
I don't believe that we'll be able to develop an index so that each morning we can get up and say the internet is this much better. It's exactly as Ed said, it's going to change.
All right. No, I'm not naive enough to believe that you could have an index to say the internet is this much better. But I do think that it might be an overstatement to say that the kinds of methods that have been used over the years to deal with problems that have occurred in networking are suddenly no longer valid because we're in this new internet or IP-based world that, we had a problem years and years ago. Just one example, we had a problem with toll fraud in legacy communications networks. And there's all kinds of other things, bad things that were happening in communications networks, and operations people and communications companies were working every day very hard to deal with all those things. They had a whole bunch of stuff to worry about. They didn't just have one metric. But they probably were worried about toll fraud as one of the things they were worried about. And this was a business problem.
No, I mean, on toll fraud, I agree. Toll fraud is a great story in a problem being identified and solved. The thing is that the switches that a lot of us put in the 70s were the same piece of gear that's running now servicing TDM. I mean, if you look at the code base for our time division multiplexed 4ESS systems, it hasn't been touched in 30 years. So if you say we're going to put something in place and not touch it, not change it, then I really think you can make a lot of progress. Like I think if we were still using TDM networks, toll fraud would still be a problem. It'd just be different. So the reason toll fraud was fixed is because we were able to build heuristics and build models around an infrastructure that, at least for us, just wasn't changing. We
built a whole new signaling network.
Yeah, but it's still fundamentally, it's just not in the same space as what we're talking about here. So I feel bad. I don't mean to derail the idea that we can make progress. Absolutely can make progress. But you asked about metrics.
Yeah, I did.
And measurement. And I think that's a much harder thing. Like, I think we would all say, yeah, we made progress the last few years in a number of different areas, but now we've made more insidious problems in other areas. So I don't know. I just think the right metaphor, the right way of thinking about the problem is that it's going to constantly shift, and we should make sure we as a community are set up not to get on a path to solve a problem, but rather to recognize that there are going to be a range of problems. And if we want to get better at our interaction, that interaction should be around what's changing, what's new, and are we going to be able to deal with things a year from now that we can't even identify today? Let's focus on making that mechanism better rather than, like I think the best practices thing, like I'm sure Level 3, Dale's a smart guy. The way his team handles routing and naming and so on, I'm sure is sane, right? I don't think there's anybody on the panel or anybody in the infrastructure globally that's necessarily irresponsible. They would be rooted out very quickly. For the most part, you got operators that are pretty responsible. I think that's a good thing. That's something to build on. But where we have not worked well together as a group is sort of predicting what's next and talking about what's coming and saying, we don't have a problem now, say, for example, with wireless and mobility. We don't have worms bouncing around people's BlackBerries. We don't have viruses on people's iPhones, but I have a feeling it's coming. And, you know, that would be sort of an example of something that we as a community should be more proactive. Let's predict what's coming instead of, you know, looking at, say, DNSSEC that was, what was 95 when the original proposal was written? So that'd be my, my vote for us as a community moving forward.
I'm going to be slightly contrarian. I actually think there is a metric, but I actually think we're asking the wrong question. Right? BGP isn't important. Right? It's very important to everybody sitting up here at the table. Right? We rely on it. It's sort of important to everybody probably in the room. You rely on it. But how many people actually interact with BGP on any given day? Right? Very few humans actually interact with BGP. BGP is a tool that we use to let you communicate with some other computer. Right? That's what matters, is your ability to communicate with some other computer. There's two classes of attacks on BGP. One of them are things that prevent you from communicating with anybody, and then there are things that make you communicate with someone else. And that's actually the monetizable attacks. Right? I can keep you from communicating with somebody. I'm not going to make a lot of money out of that. But if I can make you communicate with me, I can potentially make a lot of money off of that. And that's the threat that we're worried about. You know, and maybe that money is I'm stealing your data and doing something with it. So what we can measure is not how robust BGP is, but how robust are the communications protocols against that type of adversarial action. Right? We look at the advent of SSL, and I forget which of you said, SSL was easy, right? We just decided to go do it. Except it wasn't that easy. Most people don't use SSL. Except last week somebody released a very nice exploit tool called Firesheep that made it very easy for you to, sitting on an open wireless access point like you'll find in this room, watch somebody making updates to their favorite social network and make an update as them. Right? That's the basic attack of BGP. I get to look at your traffic, except I don't have to be in the same room as you. Right? And all of a sudden, out of this high publicity, people are turning on SSL in more places. Right? So we can measure how robust the communications protocols are by whether they have transport layer security.
You mean a quantitative measure?
Sure, we can look at internet traffic and look at how much of that it has some form of point-to-point authentication or encryption on it.
I would take a combined view on the metric piece and say that I agree with both perspectives in that instead of a 2-access metric, that maybe what we really need is a 3-access metric where we are talking about the number of incidents being 1, the threat vector being the other, so what's being attacked and how it's being attacked, I think are the things that we need to measure to determine whether or not we're getting better for any particular space or any particular problem. Because I agree, you can't, you couldn't be able to say that our communication security is better if we just enable SSL, because we'll be back here having another conversation about botnets compromising or keystroke loggers or whatever, right? So it's making sure that we scope this problem or focus this problem on what's being attacked, what the benefit of that attack is, and what measures we need to put in place to react to it.
Okay. Okay, Andy, go ahead.
That's the last one. So at some point we have classified all threats against the routing infrastructure, and we covered 2 of them so far. One is physical components, the other is software and configurations of routers. But there is a third one, business threats. The longest disruptions of service between multiple one-to-one parties has been the peerings. Namely, when 2 providers decide that they really don't like one another and they will not exchange traffic. This hasn't happened very lately, so nobody talks about it, but it used to happen quite often. It's something that state actors can do if they want to, worldwide. So we are completely exposed to the threats of business or nation-driven cessation of communications between large networks. And these are very serious problems with a duration of days, not hours, as in case of misconfigurations. Typical hijack lasts, from minutes to a few hours at most. YouTube, the famous hijack, 2 hours. The Cogent sprint appearing, what was 3 days? Something like it. So there is another category of threats which is at a much higher, say, political level.
All right, thanks, Andy. We've got about 15 minutes before we're going to start taking questions. And we spent more time on BGP than I expected, but it was good. And a lot of the things we talked about are relevant to the next topic, which is, ironically, DNS, or DNSSEC. Somebody just mentioned we've been working on solutions to domain name system security for a number of years. The industry has, and that's true. But an exploit, Kaminsky exploit several years ago, started to really get some, DNSSEC has been around as this solution. DNS, by the way, before I dive into this, let me just spend a minute. The vulnerabilities in a domain name system are such that domain name system is the sort of like the directory assistance function in the internet. It's what lets you enter www.amazon.com, for example, and go to the Amazon server. You hope, and most of the time you will. Vulnerabilities in the DNS protocol suite can cause you to be diverted to a fraudulent site, and this happens to a number of enterprises, to industries, and that's just an example of the kind of thing that can happen, and the kind of thing that the DNSSEC set of extensions to the initial or the underlying DNS protocol suite was designed to remediate or deal with. One of the things. Now, DNSSEC has been around for a long time. There's been a lot of good work done in recent years by ICANN and by DHS to try to move this forward. The Kaminsky exploit that I was just mentioning kind of got folks motivated. The top-level domains are now being signed, or will be. So DNSSEC seems to have caught on, right? In some ways, a major infrastructure change is going to be rolled out top-down from the root servers all the way down to the infrastructure, to the ISPs, to the ultimately to endpoints in the network, and so it seems to have traction. The question now is what needs to be done to keep it moving forward or to expedite deployment of DNSSEC, especially now for ISPs, because that's where the ball seems to be, right? Anybody?
I think DNSSEC is inevitable. I don't think it's necessarily evil. It has the same kind of pros and cons that you see with BGP. So, for example, the Kaminsky attack, clearly the risk is reduced, right, if you overlay public key infrastructure onto DNS. You could even make the argument that certain types of botnet attacks would be somewhat thwarted. Certainly man-in-the-middle attacks thwarted. So there's a whole bunch of things that you get. But on the other side, it's a heavier response, so you could argue that amplification attacks would be maybe easier with DNS. It doesn't solve distributed denial of service attacks at infrastructure, and it's got all that PKI baggage, right? So I think, it's going to take some time. I mean, ultimately, as an ISP, I guess, I've thought a lot about this. It would take us deciding that we're going to refuse stuff that's not signed, right? That'd be pretty tough. You'd break a lot of things to do that. Right? It'd be pretty gutsy to say, all right, I ain't talking to you unless you're talking DNS. Who's going to do that? So it's sort of one of these things. I think it was mentioned earlier that they're in federal government. I think Andy was saying, I like the idea of procurement being a way that the federal government drives us. We are driven by revenue. So, you decide on big programs that you're going to buy certain things, and we're going to be selling them to you. So that may be the way to go. But I would say, it's got very parallel set of pros and cons. But for me personally, for my team, we've come to the conclusion that the likelihood of seeing DNSSEC is pretty high eventually. If you ask me how long, folks here might have some thoughts on that, but we wouldn't be able to turn it on tomorrow universally. That would not work. So hope that's helpful.
I think probably one of the things that worries me most about DNSSEC rollout, because we're actually already there and we're rolling out DNSSEC across our customer base as they opt in for that, is the operational challenge, the bureaucracy, as it were, of the PKI, right? Everybody who's operating DNSSEC name servers has to be providing their keys upwards in the chain. And quite often the registries that are upstream of them and the registrars upstream haven't really built operational mechanisms for doing so, right? So we have a PKI that's capable of rotating keys every day if we want to, but we don't have bureaucratic processes that enable us to do that in a streamlined and automated fashion, right? It requires humans to do key rotation, which isn't very robust. And that's one of the things that I worry about, that that's not a scalable model going forward. And I can't wait to see, as more and more of the top-level domains are really supporting DNSSEC, to see how their registrars are going to adapt to that problem.
So, as a sort of the DNS member of this panel, DNSSEC certainly has a place. We've rolled it out. The route is now assigned. Many of the TLDs are signed. We have our TLDs assigned. There are some second-level domains that are being signed. CommonNet are not yet signed as a TLD, so there are alternative mechanisms, but they'll be in place, as you said, pretty soon. The thing that we have not yet solved is the end user. We can certainly authenticate DNS between authoritative servers like the root servers and the TLD servers, or the second-level domains, and the recursive servers operated by the ISPs. We can solve that. But the vulnerabilities still exist at the edge, and I know the next panel will probably talk about that. There's certainly that problem, and no one has even begun to deal with that issue. There are no applications yet that actually use DNSSEC to authenticate the answer that it got from the recursive server. So I don't think it's going to be an ISP challenge. The ISPs will roll it out over time. The code exists, and it's existed for years. It's still not a practical use of DNSSEC. It still doesn't solve the problem until the end applications have that. And I believe that's going to be years.
Do you really, Rodney, I just want to ask you if this is a binary thing. In other words, until DNSSEC is fully deployed all the way down to the client, is there no benefit to be gained from it at all? Or
no, there is some. It changes the vector. It's exactly as Ed mentioned earlier. You just move the problem from one place to another. But the bad guys are much more nimble than we are. We work in terms of months and years in planning. The bad guys do it over the course of a couple of hours. So if we move the problem around, they're just going to, all they have to do is be good enough to climb over the bar. They don't have to clear the bar by 10 feet. They just have to climb over it, and they will continue to do that over time. So this is not the kind of problem that you describe. It's really one that's going to need an end-to-end solution before it's effective. And until you have that, DNSSEC is a great idea that does solve some of the problems, but it moves the challenge from one place to the other.
Does it move the challenge to a place where the exploit is more difficult to carry out?
No, it's just different.
Okay.
It's just different. I mean, the reality is, you look at, if the problem, it was more difficult to compromise at the edges, we wouldn't have botnets. But the bots are on the edges. I mean, we have stuff in the core to try and stop it, but there's always someone who finds a way to bypass what we have in the core, and we have in firewalls and so on. People still open emails that they shouldn't. They still go to websites and click things that they shouldn't. Until you're able to solve that problem, it's no more difficult. It's just different.
I mean, and I would agree. I mean, we're in the process of rolling out DNSSEC, but the issue is that with regards to Kaminsky, we all implemented solutions in the short term that put the finger in the dam to try to solve for cache corruption, and so we can move on to the next firefight. But and we're certainly seeing a lot more traction in DNSSEC from a business perspective than we have in the past, which is good. But I totally agree that the level of effort that we're doing to implement DNSSEC is just going to move the vector to another place.
Okay. one other thing before we take questions, and that is about PKI. We talked a lot about PKI in the context of BGP, and I understand that some of the original and maybe the current BGP solutions rely upon a PKI infrastructure to be in place for them to be carried out, and DNSSEC is no different, right? So, and yet in BGP, it seemed like PKI, that was one of the things that was being talked about, is a very difficult, complicated, years and years and years. DNSSEC, though, it seems like it's being dealt with. So is it a matter of, what's different about DNSSEC that's making that problem a little bit easier to deal with, or is it easier to deal with?
So I think it's easier in DNSSEC because there is one root functionally for DNSSEC, and that the root follows the same directory structure. So, the roots themselves are signed from a root key. They sign the top-level domain keys. They sign the second-tier keys underneath them. It really isn't what people think about when they say a PKI. Because when you think about PKI, you think about the SSL world. Right, now let's think about SSL certificate authorities. And if you'd like to be very scared, that's a place to look at. Right? We have certificate authorities that can sign authoritatively for any domain name they want. Right? You went to www.amazon.com. There exist country-level certificate authorities that are countries that don't always necessarily have our best interests at heart, that could choose to issue certificates for Amazon, for FCC.gov, for any of these entities, because we have no restrictions on the capability of a certificate authority to issue a certificate to anyone. Right? And that's one of the challenges we think of when we look at the PKI for BGP, is would it be more like the SSL PKI, where you'd have national level entities around the world that were capable of signing routes for anybody? And if you do, what have you actually gained? Right? If somebody chooses to engage in warfare via the internet, certainly they'd be willing to use their certificate authorities to do hostile things.
Let's go in your office and draw a picture, like go up to your whiteboard and draw a picture of what you think PKIs look like, and then draw a picture of what DNS looks like. Similar diagram.
Right.
If you try and draw a picture of routing and BGP, be a totally different pigeon splotch on your whiteboard, and I think that sort of visually would just give you an idea of why it's been easier to match the two up.
Okay. We've got about 15 minutes before we break, so what I'd like to do right now is open the panel up for questions. And there's two ways to do this. We've got questions that have come in over the internet, and also if those of you in the audience have questions you'd like to ask, we have microphones here and here that if you would go to a microphone to ask your question, I'd appreciate that. Yes, sir.
My name is Ben Cobb. I'm with Public Technology Institute. Mr. Amoroso's comments were very startling, very interesting. And my question is, to what extent are we going to see more action by ISPs to address customers at the individual level who are operating compromised computers? And what might be the Commission's role? Since the 1940s, whoever you are, wherever you are, if you are a party that is operating a radio transmitter that is operating out of spec, unlicensed, causing interference, off frequency, wherever it is, sooner or later you will get a visit from this agency. But if your computer is spewing out malware and compromised by botnets and attacking other computers or part of a network that is doing that, it's very unlikely that the Enforcement Bureau would take an interest in that. So is that a matter of authority under the Communications Act, or might we see in the future the Enforcement Bureau getting more involved in this type of issue?
I certainly have a thought on it. I don't think it's a matter of enforcement. I think it's a matter of improved software engineering. Like I've been asked, should we, and I bet everybody in the panel here has been asked, should we consider turning off or blocking customers who are infected? And I say, yeah, we could be pretty accurate at doing that. Turn everybody off. Everybody's infected. Like the Zeus botnet, the thing used 4 zero-day Microsoft vulnerabilities. So do you blame Microsoft? I mean, you don't make a lot of progress by doing that. What good does that do? The bottom line is that software engineering is in a sorry state right now in 2010. There isn't a person in this room who would disagree with that. And that's where I say the problem lies. I'd also say that we need to remember that the most secure line of code is the one that doesn't exist. And this, the idea of lighter clients, internet appliances hitting cloud infrastructure is a much better architecture than my mom, who's a nice lady but not a very good system administrator, having a fully configured Dell tower under her desk that's attacking China all day. You know, over a FiOS connection that, you know, makes it look like a little mini data center. That's the problem. She does not need that power, and we've built an architecture that has distributed that power around the globe. Distributed power is cool. Akamai is a good example of a company that's happy to sell you distributed power. They know what they're doing, but distributed power to citizens is a very, very bad idea. So we got ourselves in a little bit of a pickle.
I just want to step in with that. You know, I think the point you bring up is actually a critical point, and I think that the second panel is going to talk about it. We have to find a way. There's a regulation that stops us from fixing machines that are broken. There are terms of service that may allow, or an AUP that may allow an ISP to make some changes, but we have to get over this hump that allows the bad guys to distribute their code. In many cases, we have the equivalent of antidotes for that, but we're hobbled by regulations from actually executing it and fixing someone's machine remotely. And that's probably one of the most likely ways we'll be able to solve a major part of the problem very quickly, except that globally there's a restriction. There's some activity that's going on at the moment in Holland that I think is now public over a particular piece of malicious software. Holland, the government has actually taken action to try and solve the problem. They actually have pop-ups that now appear on infected users' machines. They're actually doing it by downloading a piece of software, an EXE, which is quite radical. And there's actually an outcry from many parts of the community at the fact that the government is doing that. And the government is faced with having to make a decision. Do we allow people to be infected and to lose their money or to have things stolen? Or do we help themselves? And it's a real tough thing. It's something that I think we really have to do. If you're talking about where regulation, you know, and it's a word that none of us likes, I think it's the thing where we're able to fix regulation, bad regulation that actually stop the good guys from actually fighting the fight. So I would suggest that that's something that you might want to look at, rather than just turning someone off. Turning someone off results in a business load. People call and say, why did you turn me off? And you just can't afford to deal with calls like that. I know that Mike Redden from Comcast is going to talk a little later, and they've done an excellent job, obviously a large consumer network, in being able to help consumers. But it's a really tough problem.
Let me try and answer the other part to your question. And the fact is that the question you're asking is a question that we are looking at right now. And that's when Josh was up here, he mentioned that we were working on the Cybersecurity Roadmap. That's one of the issues that we're looking into, is what can be done to create a more secure environment for end users, particularly residential end users that are connected to the internet. And as Rodney was just saying, the second panel today is designed to probe those very issues. So see if any of the things that you're wondering about get answered there, and if not, then there'll be time at the end of that panel. Thank you, sir.
A lot of the challenges to try to put in place some of the security controls seems to be just not business sound. You know, there's too much cost involved. What kind of incentives do you guys see, you know, shy of government subsidies, to avoid things like liability and regulation and those types of mechanisms? What kind of financial, economic incentives do you see being able to push that and tip that over to the point where the margins, it makes sense to do some of these rollouts of what we know would work?
So I think we want to stay away from the idea of subsidies, right? I think most of us up here don't want the government to try to pick winners and losers and subsidize behavior, right? But the government is a buyer, right? So when the government says, we want to buy DNSSEC as part of our DNS services, that's not a subsidy, right? That's the government as a consumer saying, we feel that level of security is important for us, and therefore we'll pay for it. And when the government decides to do that, people will build it. And then once you've built the technology, you're really happy to then go sell it to everybody else, right? And so that becomes sort of a market-based subsidy. And that's, I think, what a lot of us have asked is, if a secure form of BGP is desirable to the clients, right, where the clients are not just end users, but also consumers at the server side, then they need to be asking for that and putting their money where their mouth is. And that's the type of subsidy to change behavior, right? That's a financial incentive. Given that the operators have not found a financial incentive to go implement secure BGP or SOBGP or do research into something else, it's pretty clear somebody has to say, hey, we want you to build this, and we'd like to be part of part of your network that has secure routing, and we'll pay a premium to do so. Right? You're not going to get security that is not in the best interest of a provider without paying a premium for that security.
Do you find that in your service level agreements today, in your customer base today? Is that happening?
And absolutely, we see customers who are paying for security services, and that incentivizes us and our competition and other business partners to improve their security services around that area.
I also want to say that I'd caution to make sure that at least based on the conversations we've had today, that when the government or any customer is asking to purchase services in the belief that it's going to move, that it's going to solve for a threat, that they're actually buying what they think they're getting. I think we've all agreed here today that purchasing or requiring secure DNS or secure BGP isn't necessarily going to provide secure DNS or secure BGP. It's going to solve for a series of threat vectors, and that problem is going to move on to another area of compromising DNS and compromising BGP. So I'd like to think that as a collective community that we're pretty adaptive and pretty fluid in being able to identify disruptions to reliability and integrity of service, to solving those problems in the immediate. I think that we don't necessarily have the foresight to go that extra step in solving some of these larger problems. But we solve the problem of the day and then move on to the next threat vector that's impacting the infrastructure. So I completely agree with what the panelists have said. I just want to make sure we all agree that purchasing secure DNS isn't necessarily going to secure DNS.
One other thing I think that's important for the whole group to recognize is that there's this prevailing view, I think, in government, that in industry we make these decisions based on financial considerations. We say, well, do we do this security thing? How much does it cost? Well, it costs too much, I'm not going to do it. I've never had that discussion in 25 years. It's always around complexity. It's always around risk. So most of the time when we opt out of doing something that's perceived as potentially having some security benefit, it's very rarely because, wow, there's this expensive thing, I can't go. It's always around, if we do that, we might break more than we fix. We might cause more problems in the transition than we fix, like IP version 6. Nobody disagrees that the end state in version 6 is not better than version 4. It's getting there, right? There's a lot of risk in touching every piece of equipment and changing the underlying data structure associated with that. It's not that there's this cost, it's that we're fearful that we're going to introduce complexity, which is the opposite of security. So I just want to make sure everybody, here's, at least from, I suspect the others would agree, we don't sit off in some boardroom and make these financial judgments. For us, it's always around risk management. Is this something that, where the security benefit far outweighs the complexity and risk of deployment and integration? And for BGP and DNS, at least to date, BGP probably less so, but DNS, I think it is moving forward, albeit very slowly. And the slowness is based on risk, right? It's not because you don't have the money. It's a risk thing. Okay, so I think that's important.
Casey.
Thanks, good question.
Hi, Casey, UC San Diego. So by way of disclosure, I'm funded by DHS, the cybersecurity program, to do some measurement work that probably couldn't answer any of the questions that have been addressed today, or if it could answer it, it would be by accident, not by design. So because I've watched DHS go through this for the last few years, and I know they've spent at least 2 years writing a cybersecurity roadmap themselves, I'm interested in how you see the FCC's role in this space, complementing or working with the DHS or not, or what are you doing that the DHS isn't doing, or vice versa? And that's a question for the FCC. And then a question for each of you guys, because it hasn't really been directly answered here, is what do you want the FCC to do in the area of cybersecurity? Or if the answer is nothing in the area of cybersecurity, in any other area, take 30 seconds and just let me know, because it's really unclear to me how what role the FCC can play to help you guys right now. Rodney sort of answered the question in terms of give me something that lets me help the end systems fix themselves. That's more of what Congress needs to do if it's a legislative change. So I'm really worried about what the FCC can do in its current form that would help you guys, primarily with cybersecurity, but feel free to riff. Thanks.
I'll take the last.
Asking you the first one.
all right. Thank you, Ed. The panelists are in charge now. Okay, let me answer the first of your questions, Casey. So what does the FCC fit relative to, say, DHS well, DHS, let's talk about DHS. I mean, two components of DNS, or DHS rather, that we work with closely, Doug Maughan's group, and I think you know Doug very well, as well as the group on the sort of the infrastructure protection side. So on the infrastructure protection side, we work with them more in their operational role. We don't, at least right now, see ourselves in an operational role. It's not, that's not how we see ourselves today. What we're looking at today is what can we do to say leverage the good work that Doug has done. Doug has done a lot of good work in R&D on DNSSEC, and now he's getting more and more into secure BGP. And are there things that we can do to help move the ball forward, given that it's already started? DNSSEC is a very good example where there's momentum. Are there things that we can do, given our relationships with ISPs, to help move DNSSEC deployment from the root down into the ISP infrastructure? And so that's where, just in general, in abstract, that's kind of how I see our role. It's more as a policy role, not an operational role, not an R&D role, but somewhere in between, and leveraging our relationships with ISPs to help get things done. Ed? Now, you're going to tell me I shouldn't do anything, right?
Well, I'll say something first that's very politically correct. Fostering dialogue is always a good thing. So we all have good relationships with the FCC. So I think it's been I think it provides a very reasonable and a very clear mechanism for fostering the dialogue, for having debates, for having discussions, for having seminars. That makes perfectly good sense. As I said, if you ask me what I think we should all be doing and what role not just FCC but all government components should be doing, I think this idea of preparing for a battle that we can't define today is the way we need to start to operate. It seems I spend a lot of time in Washington, and we're always talking about the problems of yesterday and 2 years ago and 5 years ago and 10 years ago. I think somehow we need to recast that dialogue around what's coming. What do we see? And for everyone on the panel here, we would say botnets. And botnets in mobility, mobile bouncing around horrible botnets that are clogging our ability to use mobile telephony. Have you had a day yet where you came in and you had a directive at work where they said, don't turn on your BlackBerry? Why? I don't know, just whatever you do, like it's probably infected, and if you do, all this awful stuff is going to happen. And you would go, okay, what do I do? I mean, have we had a discussion around that problem? Those are the types of things that I think are moving forward. And I think too often we spend our time and energy on problems that, for the most part, I wouldn't say they're in cruise control, but there's certainly things that we're handling. So that would be my vote, that not just FCC, but government in general needs to spend more time thinking about the next problems than, trying to rehash the old ones.
Do to help you with botnets?
With botnets? Good question. I mean, I think that, you heard from Andy a couple of times that the thing that we hear, is all of us, I think, on the panel work for companies, the thing that we hear is the drumbeat of capitalism, right? We like to have people buy things from us. That's what moves us. A lot of times, you go to some government meeting, and you see a bunch of industry participants, and they're all there willingly, participating, doing this and that. Ask them how many are customers of that particular agency, where the agency's spending money. Probably all of them. They all view that as a sales event, not as obviously this is not the case. FCC is a different entity for all of us, but we hear sales, right? That's what drives us, revenue. So the best way to get us to move is to set the procurement fabric in a manner that makes sense. Now, I think the only solution that makes sense to me for botnets, the only one, is to simplify the end user profile. Simplify those devices that end users are handling. Like the idea that the ISPs would police the malware. Well, that takes us back to, how about we think about Carter phone then? Let's go all the way back to that. If all the ISPs are responsible for the security of the end user devices, well then I want a factory where those end user devices go through my factory and I validate them before they go on our network. Because if you do a bad job, then I have more work. So do a better job to my specification, then I'll take the responsibility. We don't want to do that. That's ridiculous. So I'm just saying, I think that's a dead end. But the problem begs a solution that none of us even want to think about, changing the fundamental nature of software engineering. I don't think people who have music degrees should be allowed to write software. I don't. I think it should be just as hard to be a software engineer as it is to be a surgeon. You should have to go through a period of apprenticeship, proper training. You should be at least 45 years of age before you write your first live line of code. I'm just kidding. So, but I mean, if you really want you want government to dive into some tough problems, dive into that one. There's a nice juicy one for you. And it touches all the things that government's good at. Fostering education and, trying to drive initiatives around, future-proofing our society over the next 20 years. What's the future of software engineering? Those are great topics. So I've talked too much. I'll shut up.
10 seconds or less. Anybody have anything they want to add?
I put it in three camps. I put it in the camp of less regulation is always preferred. Removing regulation that restricts our ability to be reactive. As an example, being able to disinfect, as an example, would be one that I would talk about. And then I would also agree that creating collaborative communication forums that allow all of us to get together and discuss not a specific single vector to solving a problem, but what the multiple phase approach is to solving a problem, right? So on botnets, it's everything from software development to vendor disclosure of exposures when they're made, when they're made aware of those exposures, to how ISPs can either garden wall or fix infected machines on their network, right? So it's how do we get all the right parties together, not just the ISPs, not just the software vendors, but how do we get everyone together to discuss an attack vector and discuss the multiple phase approach to solving that problem through a common dialogue.
Anybody else? Okay. Real short, Andy.
Very short. I'm thinking, that your examples about the infections and who should take care of computers are very good. I think that in software writing and production of mobile devices and regulation of safety of those devices, we are more or less where production of medicines and drugs was at the end of 19th century, where radium was a very good drug for beautification and curing of teeth and things like this. So I tend not to believe that it's a responsibility of service providers to clean up people's desktops and laptops. It's the industry that produces them that should be held responsible. And we are simply not there technologically.
Okay. Let me now thank our panel and ask you to join me in doing that. And we're going to take a 15-minute break. It's about 25 of now, give or take. So 10 of 11. We'll be back in here. Okay?
Yeah.
Second panel first to thank them for their time and talent here today. But to introduce the second panel and the topics that we'll be talking about, some of these things came up in our discussions the first time, and it's sometimes difficult to separate these issues. But in my mind, I do at least. And what we'll be talking about now are issues that directly affect end users one way or the other. And I further divide that into issues that are more, I'll say, client-side or user-side issues, and issues that are more server-side issues, so website issues and email issues, so forth, the infrastructure that's providing content, or not so much connectivity, but more content, although not exclusively content. So, so we'll be talking about those two aspects of this problem of malicious code, of malware, of bots, of DDoS attacks, which originate primarily from the edge of the network. From, I think it was said in the previous panel that at least half of us here are probably infected one way or another, maybe most of us by bots. We probably wouldn't know it if we were, because that's the way they're designed. And they are now tending to be one of the most, one of the attack forms that folks are most concerned about. Bots generate denial of service or distributed denial of service attacks that can be directed at communications infrastructure, can be directed at servers across the network, websites across the network, and so forth, and be very disruptive and disabling. So we'll be talking about those issues and what can be done both to create a safer online environment for end users, particularly residential end users. I think at least in the enterprise market, there tends to be some more sophistication about configuring and managing security, and maybe more resources available, certainly in the large enterprise market. In the residence space, folks tend to be less sophisticated about these things, less inclined to want to deal with them. And so what I'll be asking or wondering about is what can be done to help make it easy for end users to have a safe online experience. And there are different ways to do that. We will probably not be talking as much about ways to create a more secure software infrastructure, although that's part of that's obviously part of the problem, and maybe the biggest part of the problem. But there's also things that service providers can do, entities that we've got relationships and work with closely. So when it comes to the FCC and what we can do in this space, we tend to think about what we can do working with ISPs to make a difference. And so I'd like to first now introduce, or ask the panelists to just spend a very brief minute and introduce themselves and their titles, and then we'll get started. Jim?
Hi, Jim Lewis, Center for Strategic and International Studies.
Bill McGinnis, Director of Data Services for Internet Identity.
John Morris, the General Counsel of the Center for Democracy and Technology, and I also have served as co-chair of a working group of within the FCC's CISRIC Council looking at botnets.
Michael O'Riordan, Distinguished Engineer at Comcast.
Ari Schwartz, Senior Internet Policy Advisor for the National Institute of Standards and Technology.
Bill Smith, Technology Evangelist at PayPal. I'll do my best to channel Michael Barrett.
Yeah, forgive me. I should have announced Bill is sitting in for Michael today, and we're grateful that you could be here. So thanks all the panelists for joining us today. And let's start by talking about some of the client side or the end user side issues. And the first question I'll ask is, what are some of the things that ISPs can be doing, without getting into specifics necessarily, but what role can an ISP play in creating a more secure online environment for end users? And so let me just throw that out. See, anybody care to respond?
Sure. I'm not an ISP. PayPal's not an ISP. We'll come out with some ideas. We see ISP as sort of in three categories: transit providers, communications providers, and connectivity providers, and we think each can do something. In terms of transit providers, we understand that they're already monitoring significant amounts of traffic in an attempt to or just their normal course of operations, they actually frequently know which servers and which individual machines are part of botnets. This is not by doing deep packet inspection, but simply by looking at packet headers. We believe they have the technical means to drop that traffic. But most of these providers are unwilling to do so. We believe a reasonable interpretation of current law allows them to do so, and we would like the FCC to help validate this assertion. We think that could significantly help with the issue of botnets and the like. In terms of connectivity ISPs, we look at what is being done in Australia, the Australian Internet Security Initiative, where they take feeds of suspect IP addresses in from sources like PayPal, eBay, Yahoo, Google, etc. And this organization, government organization, agency, then forwards those things to ISPs who voluntarily participate in the program. And then the ISPs communicate with the consumer, either by snail mail, email, whatever mechanism they choose to. This is done on a very small budget, begun in about 2006, 2007. We believe it hits about 90% of the consumers with just 80 ISPs in Australia. And it's been demonstrated as an effective private-public cooperation. The third thing is on the communication providers, inbound email, phishing spam, that there are some emerging standards, domain keys, identified mail, author domain signing practices, sender policy framework, DKIM, ADSP, and SPF that would prove effective in helping to mitigate spam and phishing attacks. And these are things that can be done that would benefit our grandmothers, not the system administrators, the people who really don't know and never will know the internal workings of a computer. And I think that's something we as an industry need to understand is these computers have become truly consumer devices. And for those of us who remember what a dial telephone is, you just picked that up and you got dial tone. It worked. We need to make computers basically the same way. That's our responsibility.
Anybody else? Michael?
Yeah, I think it's interesting. I mean, certainly, you can see I work for Comcast, and we've launched our Constant Guard program, where we actually do inform customers when we believe them to have been botted, which we do without, deep packet inspection. And we've published on occasion the way that we do actually go about it. But I think there's a variety of things that ISPs can do. I mean, we can help the customer by detecting that there's an issue. We can offer them tools which allow them to remediate that issue. And we can be, part of an ongoing education process which teaches them to use the internet in a way that's both successful for themselves and ever so slightly suspicious in terms of, they've got to be careful when they're doing things. I mean, and I think it's a very valid point. I mean, we need to move it. When you pick up a telephone, you do not expect to get a bacterial ear infection. The trouble is now when you run a PC, there is a good chance you're going to get a virus or a bot.
It hasn't been very long, I'll say, without getting specific about how long, but it hasn't been all that long since ISPs weren't doing a whole lot in this space. Okay, it's a fairly new phenomenon that ISPs are getting more engaged, and I guess what I wonder is why hasn't there been more done here? And now that we're starting to see more things happening, what's causing ISPs maybe to do more? And is that even a false conclusion? But is more happening, and is it enough?
I think the problem has scaled up massively over the past couple of years. I mean, it's gone. If you go and talk to any of the AV suppliers, the numbers of signatures they're writing per day has gone. Back in the beginning of the century, I suppose. Yes. But back in 2000, they were writing maybe a couple of hundred signatures a day. Now they're writing a couple of 100,000 a day. It's gone, so that the problem itself has got massive. And you've got to bear in mind that the toolkits and the ability of the enemy to actually to mount an assault on ISPs has got very significant. You go out there and there are toolkits which give you the latest exploits. There are toolkits which give you the ability to write your bot. There are toolkits which give you the ability to encrypt your bot. There are outsourcing services so you can break those tedious little captchas that you run into, where people in third world countries go and type them in for fractions of a cent and render them in real time. This is an industry we're fighting, and an industry we're dealing with, and so the problem has scaled up massively in the past couple of years.
I think it's the way that the types of attacks have changed over time, right? At first, things were more spam-oriented, and sort of malware came to become a much bigger part of this. Certainly, spyware was a piece of that. So and now botnets obviously are where we're seeing the way that we're seeing most malware being distributed. So and the types of attacks that we see come through botnets. So obviously, none of those problems ever went away, but in terms of the role that the ISP can play, it's a lot more clear in a botnet than it was going back to spyware or something like that.
Yeah, I think the effectiveness of the typical antivirus and the typical solutions that had been in place, as Mike was talking about signatures and creating new signatures, the general effectiveness of those technologies has waned such that the most effective place to deal with various infections, various botnets, malicious activity is kind of at the carrier level, and the general access and availability of the customer to actually get to these either communication points or infection points, those types of things.
What could be done to encourage more ISPs or ISPs that are currently involved in helping to improve things in this space to do more? What could be done to create incentives to move things in the right direction there?
Well, just looking at the work I've done on the CISRIC working group, working with a lot of ISPs, I mean, I have the perception that, although certainly Comcast is leading the way, most of the major ISPs are looking very closely at what Comcast is doing and are themselves already doing more and more. And so I think the major ISPs are moving in the right direction. There's a much bigger problem with smaller ISPs that simply don't have the same kind of resources that large ISPs do, and how we can kind of make resources available. I mean, it may well be some effort that ISPs can kind of come together and to make some tools available, tools that the larger ISPs perhaps have developed, but then can make available to smaller ISPs that don't have the resources to develop them internally.
As part of my role at Comcast, I also chair something called the Messaging Anti-Abuse Working Group. And we've been working there with a bunch of ISPs and have come out with a significant number of best practices, which are actually mentioned in a lot of the CISRIC documents. Which they encompass a variety of things, and one of them is what should an ISP do if about bots on its network, and I think there's a lot of work going on, and I think John's absolutely right in that it is a function of resource. For the larger ISPs, this is something that there's more resource available to do, but for the smaller ISPs, it's they're engaged day to day for just keeping their business going. And this is just yet another thing. And if they've got to then do this is something that probably the resources aren't available for them so easily.
Well, and it's an interesting situation too that everyone in the equation is dealing with. Obviously, you've got the software issue, which we won't get into, but from the carrier side, and again, Comcast is leading, and Mike, personally is leading the charge on this. But it's a very tough situation to frankly, have to be the person, I guess, holding the bag that has to communicate with that customer that in all likelihood that machine is now a brick, and everything that you have on it, and your best bet is to just wipe the entire machine and whatever you have on it. And so it's kind of a hot potato in trying to figure out who wants to end up, making that call to the customer.
I want to poke at not that. But some of the obstacles, some of the things that might be standing in the way, and one of them, I think, might be the fact that the problem has scaled so much, or one of them might be that the problems have changed and are, there are different threats that need to be, one of them might be the customer care issues associated with reaching out to a customer and conveying that message. Another one what we haven't talked about yet is that there might be policy things, regulatory things that are in place that create disincentives for ISPs to be more aggressive in this area. What do you all think about, are there others that I've missed, or what do you think about any of those ones that I've mentioned?
I think you talk about the policy side. I think it's interesting. If you go to security conferences and you talk about the concept of offensive anti-bot operations, which is effectively what the Dutch police force, the high-tech crime unit, is engaged in with the Bredo Lab botnet that they've just taken control of, where they are basically loading new code onto already infected machines to produce a pop-up. There's a sort of, it's almost like a groupthink or accepted wisdom, oh, you can't do that. But the fact is, that is probably going to be a way that in the long term, if you can get control of a botnet, to let the customer know they've been infected and switch them off. A lot of these bots have kill switches.
Mm-hmm.
Well, yeah, and I think too with the research that's going on, I think the single biggest bang for the buck actually possible right now is on the carrier side, but I think they need to be given, on the regulatory side, I think they need to know that some of the tactics that they can take in terms of, cutting communications to infection points, cutting communications to CNC servers, data that's out there, data they can put in play, that it's okay to do that. And, because as soon as you start cutting an ability for someone to go somewhere, then somebody's going to get angry and then lawyers get involved and it turns into a big mess. So I think from a regulatory perspective, whether it's the FCC or whoever, ends up having that ability, the ability to say that, in these certain circumstances that taking this type of activity is okay to do. And in a lot of cases you can, again, I think it's the biggest bang for the buck.
I think this leads us directly to the role of the question of what's the FCC's role. Right? There's a set of issues that we haven't mentioned that have come up, I know, but liability, right? If you're going to take some action, if you're the service provider, what's your liability? So we need to scope out either the scale of liability or the restrictions on liability, some sort of safe harbor. We need to look at cost. How costly is it for people to take these for service providers to take these actions? How do they recover the cost, right? I presume there's a cost issue involved here, and particularly for the smaller service providers. There's an info sharing problem, right? And we've heard that today in the first panel. A lot of the service providers know what's going on in their network. They may not know what's going on the other guy's network. And certainly they don't know some of the details of advanced persistent threat that will be available only to government sources. So how do you pool these things together? How do you get DHS and other people involved, right? Finally, there needs to be some clarity on all these things, and this may end up being a regulatory process, but at least at the beginning you need to say, here are the issues, here's some potential solutions, here's the role. And I always ask, who's going to do that? If I had to choose between DHS and FCC right now, and I think those are the two candidates, I think it's preferable to do this at FCC. Not because I don't love DHS, I do, they're my best friends, but because you guys work with service providers now.
So let me come back to the point that Jim just made about DHS versus FCC in a second, but first let me say, in working with a lot of ISPs on the botnet question and kind of looking at best practices, something I heard a lot was, oh, if we do X or Y, we'll get criticized on net neutrality grounds. And I can say as a very, very strong advocate for net neutrality, and in fact net neutrality rules at this commission, that I actually don't know of any significant net neutrality advocate who would say that responding to security problems is a net neutrality violation. I think that in all of the neutrality proposals, security issues are not net neutrality problems. Obviously, one needs to give some, cabin that so that a security excuse doesn't then swallow a whole lot of other practices. But I really don't think that there is a real regulatory barrier to service providers taking most of the action. Certainly, I don't think there's any barrier to the actions that the providers are basically doing now and the good practices. going to the question that Jim raised as to, should it be the FCC or should it be DHS looking at the bigger picture? I mean, I think my organization has two concerns. One, I think DHS has been already very, very active in this area for frankly longer than the FCC has, and we have a concern about regulatory duplication and kind of tension and taking these taking all the actors here and having them have to pay attention to two different places rather than one. So whatever happens, coordination is absolutely critical, and we shouldn't have overlapping efforts. But we also have a concern that a lot of the problem here is at the endpoints of the network, not within the network, and the FCC does not have clear, obvious jurisdiction over those internet endpoints. And other agencies, like the Federal Trade Commission, has more jurisdiction over internet endpoints. So it's not clear to us that the FCC is the right focal point for this.
I have to say I've kind of given up on the endpoints, and you heard some of this in both the panels. We had National Cybersecurity Awareness Month last month. A complete waste of time. Just forget it. Right? Why not call it National Cyber Sadie Hawkins Day or something? Where, we're never going to get the edge to be safe. It's never going to happen. All right. And we are in the process of a change in technology that's moving, as I think Ed Amoroso described, moving us away from the point where the end user is going to be the focal point for activity. That was the old days. That was the hobbyist PCs of the 1990s or the 1980s or whenever the heck. We're going to be doing something different, and that's going to put the focus on the service providers. And then you do get this legitimate question, do you want DHS to be working with the service providers, or do you want some other agency? Most of the times I usually prefer what we call first-party regulators, right? So DHS or FERC, go with FERC. DHS or some other agency, go with the guys who have the relationship. But it is an open question.
I think, while I agree with Jim, and I've said that in this room before on education, on the education point, I think that there is, that you can't just say that there's one answer to this problem. I mean, it's true that the problem's not going to go away. That doesn't mean that we give up on trying to solve it, right? So, which I'm not saying that that's what Jim was saying, but I do think that you have different pieces that come in and solve the issue. I tend to think of it more like if you think about fire safety, right? We're never going to have an end to all fire accidents, right? But we can come up with different standards and different technologies, different policies that help us mitigate them. Building codes, fire smoke alarms, fire-resistant clothing, firefighter gear, all of those different things kind of go into the different pieces of it. There are some places where more of that focus happens than others, but all of these different agencies are involved. Everyone that people mentioned, certainly you can also put DOJ in there, who actually go in and have shut down the bots, right, and working with DHS. And you also have my parent organization, Department of Commerce, working with companies, et cetera, trying to solve some of these issues as well, working on DNSSEC and other issues at the root. So I think that there are a whole range of different organizations involved. John talked about coordination. I think that that's really the key. There's also this role of government as convener, and I think that that's important too, as long as we don't have every agency duplicating every convening role, but some taking leads in different areas. Something like information sharing, we don't have to have, I get concerned about writing regs that have reporting requirements at this point in time while we have the kind of a change in this discussion, but it's something where we can get the ISPs together and figure out how to do measurement and metrics in this space, come up with something that can be adaptive, that can be reported somewhere, maybe to an academic institution, NGO, something like that, rather than setting up requirements that are sort of hard to change down the road, and that could help us to do better information sharing.
For the last 5 years or so, we've been measuring spam at Morgue. Now, admittedly, Morgue's an international organisation, and so the definition of spam was a little tricky if you've got lots of countries, some of which don't even recognise spam as existing. But so we eventually defined it, and that's been very useful for us to at least keep track of where the problem's going. And I think one of the big problems is that actually getting some measurement of what the bot problem is, because it depends. You can hear, one vendor will say there's so many bots on the network, another vendor will say there's, a different number of bots on the network. We say there's something else, and there's no consistency. We don't quite know. We know the sky's falling. We just don't know whether it's going to bounce gently on our head or hit really hard. And the other bit we don't know. I mean, I think this is a fundamental issue, and I've been trying to stimulate some research on it. Is along the lines of how long does a bot last on a PC, on an end user? I mean, does it last a month, 3 months? If you're the sort of person that gets a bot, are you always going to have one because that's just going to be it's going to be part of your life from now on. I mean, we don't even know those kind of bases, and some of that I think is pretty crucial to where we go, knowing what the problem is, what the scale of it is, and what the enemy looks like.
I think that type of information could be shared in the aggregate, right? I mean, where you just put that together, that information, publish it somewhere, and someone aggregates it, and then we have a better sense of that.
Just as we've done it, we've been doing it for SPAN for 5 years.
Right.
Yeah, that seems to be happening fairly regularly now, and I have to say I don't know. I haven't done an analysis that causes me to have a understanding of how reliable all these sources are, but there are sources all over the place for the kind of data that we're talking about here, and they're publicly available. Yeah, I'm sure they do, and so the idea that you're describing of through some process arriving at some common way to measure these things, and whether or not it's applied by rule or by some other method area I think you were pointing to is a different matter. But we're getting now into this topic of measurement, and that I'm interested in. I don't want to leave the other one just yet. I think, John, you were saying something I wanted to ask about, and that is that your view, your perception has been that there really is no sort of a conflict that needs to be reconciled between the concepts of net neutrality and what needs to be done here from a security perspective. Personally, I would tend to agree. I guess my question, though, for the panel is it while we may or may not agree with that, do we think that ISPs are acting according to that belief if they do believe it? What do they think, and what are they doing?
I've been trying to figure out how this might work, right? And so I think the way that it's not a binary thing where it's either they don't do anything or they turn you off. There's steps in the middle, and I think we see that in practice. So the first step might be, like we've seen, a pop-up window or something that says, "Hi, I found that your computer's infected. Would you like me to clean it?" Right? And then there might be a little box that says, "Don't ask in the future, just do it," right? Or you could even write it into the service contract and maybe put a little fee in or something. And that's what we want to get to. And people are going to say, oh, it's not perfect, it won't get every single one. But that's what we want to move to. We want to get consumers out of it. We want to give them some control. We want to give them knowledge. We want to give them insight. And we want to restrict what the ISP is actually looking at. But we don't want to have people trying to defend themselves because they're not going to be able to do it. Right? So when you think of a system that way, it's then the question is process. How do we get some ISPs are doing stuff like this right now. How do we move all ISPs into this sort of action? And regulation is probably not the place to start, right, for a whole set of reasons. But we have to think about a process and who leads that process and how we get to that point where we're not relying on consumers to defend themselves.
So Jeff, I mean, you asked, what are ISPs doing, whether or not I'm right, or in terms of net neutrality or ISPs shying away. I think that a couple of years ago ISPs were very jittery about doing things because of net neutrality concerns. Obviously, there was a big kerfuffle that arose with Comcast. But my perception is that they're getting over that, and that they are, in fact, on security issues, feeling that they can take action. And I think things like the CISRIC best practice effort that's coming out shortly will help in that process.
I mean, in fact, I'd say, Michael can correct me if I'm wrong, but I've heard nothing but praise of what Comcast has done in this space and taking leadership in this space. So to me, that seems as though that it shows that ISPs can go into this space, and if they think about it in the right way and go forward in that way.
And I mean, I've been in lots of net neutrality meetings over the last year, and I've never heard the word constant guard as you know, a topic of discussion.
When did that become a term of art, so to speak?
Well, the actual author of it is in the Jay sitting over there is the author of that, and we've been doing it for a little while. It's interesting though. Constant guard was first used by the U.S. Air Force in about 1954 for some nuclear program.
Well, I don't know if it's relevant here necessarily, but you know, we're also just talking about one half of kind of the infrastructure issues that we're dealing with, and I don't know where this falls down, but I'll throw it out there. I mean, obviously we have, you know, a problem with the kind of core infrastructure in terms of the various hosting providers and the like that are providing, you know, for the websites that are providing where the content, you know, is stored, and you can look at the data there and see that, you know, we're basically, you know, kicking our own teeth in terms of our infrastructure being, you know, used against us, and the responsibility of people that provide those services is
We're going to
obviously
get
way
to
up in
that
question.
next.
Okay.
I wanted to decouple the server side threat from the consumer side,
Okay.
you know, issues that we're talking about now. And yes, Bill.
Yeah, I want to chime in on the, you know, our ISPs basically reluctant to do things. And I agree with John's comments that there seems to be if not a sea change, you know, at least a slight change in that direction. I think the ISPs could benefit from some very clear direction, however, stating that this is in fact acceptable. Jim mentioned safe harbor. We may need to do some things in that regard. In addition, okay, so we're looking at, in essence, botnets now. Going back to what Ed Amoroso, one of the things Ed Amoroso mentioned in the last panel, we need to be future looking. So today, the ISPs are beginning to feel comfortable in saying, we can do something about botnets. But what will the next attack vector be? And what happens when it potentially crosses the line, okay, for today on net neutrality? What will the position be? We need to be able to, without going too far, give some direction, I think. And we need coordination, cooperation, and lots of communication amongst a broad set of people in order to help establish those directions, I think. Also, in terms of whether DHS should lead, FCC, Commerce, okay, we see these things as industry. We see lots of requests for comments on things. And frequently they come in within just a few weeks of each other. And it's actually, you know, can be difficult for us to respond. We'd like to see a lot more coordination amongst the agencies. We think that would be healthy. We understand the need to be separate, but if we could find a way, you know, as a larger community to come and discuss these things, private, public, I think it would be a good thing. It would help establish what some of the direction might be. And then people would have some clarity about moving forward.
The big policy issue, Bill, on what Bill's saying, the big policy issue is how do we move away from a disaggregated approach, right? That's the direction that technology is moving. So we need to keep up with that in the sense that we need to stop looking for disaggregated solutions, point defense. And so for me, the big issue is how do we get a more aggregated approach? And part of that will be clarity in responsibilities, clarity in authorities, right? And so that may not require any regulatory or legislative change to begin with. You might just want to say, here's what we think you can do, here's what you are responsible for, right? And if just laying that out would be a good start, but it's time to move away from disaggregation.
I will say, I'm not suggesting I can speak for Howard Schmidt, but I would say that the White House has done a very good job in terms of setting up coordination groups on these topics and to getting that discussion flowing. I mean, you could spend pretty much all your time on coordination calls alone on cybersecurity. The issue is that it's so complex and there's so many moving pieces, and we are focused on the point solutions in certain spaces to try and get things out the door, that we end up get to this point where people have different pieces of the puzzle that they want to try to get an answer to. So we have to do a better job at getting that message out in a more coordinated way. So and that includes working with the independent agencies like the FCC and FTC better.
And let's. I might have one or two questions to come back to if we have time on the sort of the client side, but on the server side, Bill, the points that you were moving into. The issue here is that of sort of compromised or infected servers. And it's complicated because if we're just talking about ISPs can be hosting providers. The majority of hosting providers, or maybe I guess I shouldn't say that, a lot of hosting providers are not ISPs or not traditional ISPs. Maybe you call them data center ISPs. To their customers might think of them as ISPs, but from our point of view, as the FCC, they're kind of not traditional ISPs. And they're hosting providers that sort of sit quote off net. They're like another form of end user. They just happen to be hosting a cluster of servers. Some of those hosting providers are operating pretty clean infrastructure. Some of them are operating really bad infrastructure, and they know it. Some of them are operating infrastructure that's sort of bad, and they either don't know it or they turn a blind eye, whatever the case may be. So we've got that complexity. And so let's just think about ISPs that are also hosting providers, just so that we're talking about something that's within our traditional space. And I'm wondering now, given that infrastructure can be the source of a lot of the problems that are affecting end users, what can be done? So, for example, to create maybe a standard of care or a standard where providers like that would be incentives for them to adhere to a higher standard of care than otherwise exists. And is that a problem that's worth solving, or is that the wrong problem to work on? Anybody? John?
Well, Jeff, let me just tell you that in the next few weeks, the organization Stop Badware, which is a multi-stakeholder nonprofit that's a spinoff of the Harvard Berkman Center, is actually convening. I think the first meeting is Tuesday, the 16th of November, a working group that I've been asked to participate in, specifically focused on developing best practices for hosting providers as to how do they deal with and respond to notification that one or more of their customers have compromised sites. Mm-hmm. So I mean the kind of multi-stakeholder best practice effort. I mean, one value of that effort is that it goes beyond the carriers that are covered by FCC jurisdiction, and it can, one hopes, be useful for a broader set of hosting providers.
Good, thank you.
We also think on the hosting providers, the Commission may have some jurisdiction there, and in terms of setting best practices or establishing practices and making recommendations, it's an area that is quite problematic, actually, specifically for phishing, spamming, et cetera. And John mentioned, sort of if you report something to those folks, someone who is a hosting provider, about doing a takedown or something like that, we believe there should be some, if not obligation / requirement, but some expectation, best practice about response times. We, in our business, we do fraud investigations. We look at phishing, right? We see lots of spam, and when we make requests, some organizations respond in a timely manner, others do not. Mm-hmm. Bulletproofing sites, as an example, right? These are clearly intended, we believe, for criminal activity. They target it. They're easy to identify. Some of the others are not. But response times, things like that would be important things, we think, to put into best practices.
I think it'd be great to put them in best practices. I think one of the problems you've got is business model. The fact is, a lot of the hosting providers that sell hosting space in the US, they'll resell it to somebody else who might be in Russia or Latvia or China, who'll resell it to somebody else who might be in India, who'll resell it to someone else who's in Bangladesh. how does the FCC say get that offline? I mean, that's a major problem. I mean, one that you've got some significant problems there with just dealing with the business model of hosting, which has lots of layers of multiple resellers, and so that you may have a very good ISP in the US who's behaving in a responsible fashion, but the actual website has been sold to a bulletproof hoster in in a country that's well away from US jurisdiction, and I don't see how you're going to get response times. That's going to be a really significant challenge. It's going to be a major challenge.
Could you apply the same sort of approach? I mean, there could be two approaches here. There's if we're talking now about a hosting provider that's a more traditional customary hosting provider where an ISP is providing connectivity, right, and knows that there's something happening there that's not good. That there's an infection there. Isn't there something that an ISP could do in keeping with sort of the maybe the code of conduct, the principles that that might be applied in something like Constant Guard to say, okay, we've got an infected endpoint. It happens to be a hosting provider, not a consumer, and we've got a set of procedures that we go through to deal with that. Now, they may not be able to go and cleanse that site, right, or but they can. In principle, go so far as to deny service to that customer that's injecting spam and malware onto the net.
Block users from getting to it.
What do you think?
I mean, there's always the possibility of black holing, but I think you're asking for a very simple answer to an extraordinarily complex question that probably can't be done. Justice can't be done in just in this environment. I mean, there's all sorts of significant issues. I mean, there's issues of law enforcement. There's issues of multi-jurisdictional law enforcement. Where an awful lot of these issues are actually sorted out by the FBI attaché in Latvia or they're global. I mean, not so long ago, someone went through as a meeting I was at. A buy of Viagra over the internet, right, and where it went from, and they went through place by place where it came from, and it went through 5 or 6 jurisdictions, some of which are covered by European law, some of which are covered by US law, some of which aren't covered by any law at all, right? And this is much more, I think, is a lot harder to address in terms of a set of codes of conduct. There are things that can be done, but it's not going to be. This is not going to be the silver bullet.
One of the things we want to do is, break the problem into discrete parts, because there is no one size fits all, and so there is this issue of, how do we come up with best practices, and that probably is largely a private sector function. You do need this problem of how do you make sure the best practices are adequate. We have seen some industries that have come up with best practices for cybersecurity that were clearly inadequate, and someone needed to call them to account. So you have to have that in. Even if you come up with good best practices, and I think that this industry has done a particularly good job, this sector, you still have to make sure how do you get people to use them, right? And then you have these jurisdictional problems, right? What do we do to make sure not only the big guys who might be more responsible, that's a guess, are doing it, and some other people might not. How do you get uniformity of application? You need to ask when the best practices aren't enough, right? And that's, I think, one of the issues here. But that's when we need to start breaking the cybersecurity problem into different parts. There's a trade aspect to this. There's a law enforcement aspect to this. FCC is not going to solve those trade and law enforcement aspects. The industry is not going to solve those trade and law enforcement aspects. But there are solutions. And for example, the one that's been held up numerous times is money laundering, right? There are organizations, governmental, private partnerships that have been very effective at dealing with money laundering, right, and made it much more difficult. Not impossible. This is, of course, the Financial Action Task Force. So you might have to move in a direction that way. And so this is a very complex problem with many moving parts. The part we're looking at here, though, is more the domestic and the regulatory, I think, and the service provider role. The international parts might be a little different. ITU's tried some stuff in this, generally don't like that for a whole set of reasons, but we will have to tackle the problem, just not in this forum.
I was going to say that the FTC has brought cases against hosting providers and in some of the advertising kind of cases where there's been resellers and affiliates. making promises, where their promise has been made, where people actually know what's happening and don't do anything about it, where the security has been completely neglected. But the issue there is that their time and resources intensive, and it's a slow process to get to the point where something actually happens. We need to have while that's great, and they should probably be given even more attention to that area, and help to promote that idea that they should be focusing in that space. We also are going to need more attention to some of these solutions that are much more fast, much more agile, much quicker, and can adapt to new changes more rapidly.
Does anybody have ideas for some things that could be done to arrive at more agile, quicker solutions? Things we could do?
Well, I don't know if you can do it, but I think the data around bad things, like malicious things, not opinionated things, not that whole argument, but truly malicious things, between the data that CERT has, between the data that vendors, institutions, banks, the data is out there and the data exists. So from a consumer protection perspective, I think if you can come up with a standard, a evolving definition of, again, kind of in that malicious category, and have, the permission there and the ability there, or the cover there for the carriers to say, just for all intents and purposes, wipe it off the map. It may exist, it may be on a server out there, but stop my grandmother from being able to even get to it.
I think we can come up with best practices for industry to work together to take down hosts. They've done that before, right, in a way that's and we've heard that government was not involved in those cases at all, actually, and that they just ended up working to take them down just based on information that had been made public by Brian Krebs on his blog. So I think that there could be a lot better work on focusing on where are the malicious hosts coming from. Stop Adware has published a lot of that information. As John said, there's more attention being paid to that at Stop Adware. If we could get more of that information out there where the malicious hosts are, and come up with a quick process where companies would feel comfortable participating in and taking down a host like that, that would be something that could be effective and quickly solve a lot of problems, particularly around kind of this spam barrages that we've seen out there.
That kind of brings us back to some of the points. These might be some of the themes from this panel, but what's the best way to come up with best practices? How do you get clarity in responsibility and authorities? How do we get out of the whack-a-mole situation? And that's one of the things I worry a little bit about, is a lot of our solutions we identify a problem, RBN, right? And so then we whack RBN. And I think the first panel talked about this a little bit. Go ahead and whack them, because they don't really care. They'll just move to something else. So we need to start thinking, too, in sort of larger systemic solutions, and that's where you need to involve government in some way, without them getting in the way of stuff that's already working in the private sector. So I like whack-a-mole myself. It's a lot of fun, but it's not a good national strategy.
Yeah, if I could follow up on Jim's comments, we see that there really needs to be a long-term, multifaceted strategy. The whack-a-mole is a good example. We're always going to have to play that game, because the bad guys are going to. There always will be zero-day, right, threats. That there's no way that even by using Ed Amorosa's suggestion that only 45-year-olds write code, we're still going to write bad code. At PayPal, I don't think we have anyone above 45 that could write code. So. That might be a problem. Anyway, we see education sort of at all levels as an important thing. Really, from basically grade school on up into computer science education, there are lots of things that can be done. People need to be aware. You could look at, in the United States, seatbelts as an example. Right? It's a generational thing, actually, but there were education campaigns that have gone on for a long time. They helped. They didn't solve the problem, but they were helpful. We think things like that will happen. Perhaps more targeted, focused things at the high school and college level would be a good thing. But these are long-term solutions. They're things the government can help with. Best practices, industry can help there. And those things will evolve and need to evolve. Technical standards is another area. We touched on BGP fairly significantly in the last panel. There are other standards, right, that need to be developed. The internet is, it's largely still an experiment. I like to say that if we as technical people develop the standards and the implementations that we have in what is now today the internet, and it's being used for what it's being used for, we'd all be out of jobs, because it wasn't designed to do many of the things that it's doing. It's why we have these faults. It was an experiment and still is in many ways. We have to go back and sort of retrofit and do things at various levels to turn it into something that really is built for purpose. And then there are some things with legislation, regulation, et cetera, cooperation that can be done. But these problems are multifaceted. Everyone needs to do their part. We could do the think globally, act locally. It isn't enough to say, oh, we're going to go solve this problem because another one's going to crop up. The problems will never go away.
It's interesting that you use the seatbelt example. Right? I mean, I've heard that used before, and I don't know if is that yours or is it Jim or is that somebody? Is that?
Oh, I don't know who came up with it. The car one.
Yeah.
You know, I don't know. We need to go through it, but there's clearly an interplay between someone who will be responsible for the public interest and has some enforcement ability. I'm not shading that, by the way. Someone who has public interest and some enforcement responsibility, and the private sector. Left to their own devices, sometimes companies might not move as quickly as we want. And so someone has to encourage them, and market incentives are good, regulation is good. The kind of groups that people have, those can be good. But you need to think about this as something that won't be solved organically by itself by the private sector. Doesn't mean you want a heavy-handed regulatory approach. I'm not advocating that. We want to think very carefully about how you encourage people to start building better stuff. If you've gone through this on the software side, it's just a hoot talking to people about how they write code. It's really frightening when you get to talk to some of these companies. But it works, and so how do we encourage them to move to be a little better, right? And that's kind of what happened with cars. I mean, the car model is original cars, very bad, right? 50 years later, cars still really bad, right? And then you started to get people to say, public interest groups saying maybe we need safer cars. You had hearings, you had Congress, you had agencies. That's the path we're on. It's just how many decades will it take us to actually do it?
Yeah, the car thing, it's something we use. I know Michael has used the public highway system as a way of describing where there are rights and responsibilities of everyone. You have to have a driver's license, you do these things. We're not suggesting that you have to have a license to get on the internet, but if you go back to the car analogy, the earliest cars, they came with a toolkit, right? Because you had to repair your vehicle. There wasn't any place to get it repaired, and you had to know how to repair it, the early car drivers. Sadly, I think we're not much further along than that in the computer world. You still have to know how to repair your computer when it's infected. And yeah, I believe it will take some time for us to move from where we are to where we need to be. So in that regard, I think it's a good analogy to just for to understand how long it may take to move, even if we start now. And I think we're all pretty much in agreement. We need to do things.
Yeah, I mean, you got structural issues, you have tactical issues, and it's very easy to get wrapped up in the tactical, this is bad, that is bad. I think the overriding thing is amongst people, amongst ourselves, amongst the group, we know, we tend to have a pretty good idea of what's bad, what's going on. We need to be able to empower, the best points, the points like the carriers and the like. From a structural perspective, they need the power to do what is blatantly obvious. And not that they don't want to do it. It's just they need the cover that they can do what's blatantly obvious, which is that's bad, no one should go to it. That's bad, no one should go to it. Because ultimately, everything that's going on is basically this talking to that. And if this is bad, no one should be talking to it. And you can get into who defines it and all those types of things. And obviously, that's a very complicated issue and probably one of the reasons we're not there yet. But we probably should figure it out pretty quickly, or I'm of the firm belief we're going to wake up one morning with no power. And go ahead.
Ed Amoroso, I think, made a useful point, which is the direction the technology is moving in, and we have to think of that not only as something happening in the U.S. but happening around the world, which is it's not going to be PCs anymore. It's not going to be the thing that sits on your desk that has a toolkit where you have to sort of figure out and patch and do all this stuff. It's going to be the thin client. It's going to be more like the iPod or the BlackBerry, where you're going to have a device, it's going to connect, and the action's going to happen somewhere else. We're not going to make you responsible. We're not going to even ever try and patch your iPhone. I mean, come on. And that's the direction the technology is moving in, and the rest of the world is ahead of us. So that will focus attention on the service providers. And if we're looking 5 or 10 years out, that's what we want to focus on. That's the world we'll be in. That's the technology. What do we need to do to defend ourselves?
All right. Thank you, all of you. We've got about, well, I'm going to go about 5 minutes over to compensate for the 5 minutes that we lost at the beginning. But we're going to open it up now for questions. And let me take a question first. Okay. Let me take one from the internet. Now, you're sure this hasn't been tampered with? Sorry. You say there's 2 here, Jane? Is it,
Two from, that's the first one.
Oh, I see. Okay. I'm going to read the shorter one. Okay. Yes. Dave Jordan, CISO, Arlington County, asks, this one's actually maybe a closer fit to what we're talking about, I think. Well, no. All right, sorry about that. All right, the inter-exchange carriers at one point had daily voice conferences by the fraud prevention managers to exchange information regarding fraudulent traffic scenarios. Eventually, they created a database which contained the relevant information originating, which was then blocked by all the carriers, regardless of which carriers detected the fraud. The committee developed standards which the carriers approved and modified as needed to help prevent unwanted traffic. This effort was very successful. The carriers all met every 90 days to review the progress of their efforts, and the FCC did participate at some point in these meetings. But it was a carrier-driven effort. Now, it was not required by regulation. The question, the internet carriers and ISPs could develop a similar model as a tactical response to the issue or to the issues. Communicating the risk information could not be an issue with the technology that is available today, or it would not be an issue. So let me ask, does anybody have a comment?
I'll go first.
By all means.
Which is, I do think that there have been a lot of efforts in this space. MOG has done this, the Anti-Spyware Coalition that I ran before did this, where we've created kind of these standards to help block specific problems. And I actually have done a little map of this, of the process you need to go through to get that done. So first is get people, convene the group to get people together, come up with a set of definitions and objective criteria that you think, where you think things are going to go out, are going to end up based on people's common experiences. Then you measure based on that, which goes to the measurement point that we were talking before. You build metrics around it. Based on the metrics, you can come up with, you can refine the objective criteria and the definitions so that everyone has a common understanding of the issue. Go back in, refine the objective criteria. You have a standard based on what people can do to stop some set of bad activity out there. So I do think we now have kind of a path to getting there for certain problems. It doesn't mean that we have an answer for every problem that comes along. The question is, you know, in what is the problem that you're trying to solve that we need to make sure that we have everyone on the same page on and the same set of objective criteria around.
How do we leverage that? How do we leverage that? I mean, is that something you
well,
and I should talk
again,
about?
I mean, I think that, I mean, the question is, who is the standard-setting body, right? Is it, is this an IETF issue, right? Do we go to the IETF, bring something to the IETF in this space that way? Is it a web problem? Do we go to the W3C? I think those are the issues that you need to figure out. Who do you go to in this case? MOG and ASC were kind of created on their own around specific problems. The Anti-Phishing Working Group created on its own for a specific problem. I think that and now there's a lot more communication on this, and there's been this discussion led by CDT and Stop Adware along this idea of a chain of trust and trying to find the players and the different pieces of the chain of trust that can solve these different issues at different times and figuring out ways to work together, which I think is helpful for making that happen faster and not that you end up writing the standard 2 years after the problem has been solved. And that's really the key, is how do we speed up that development time to get to that, so that you have the companies and other government agencies, others that can participate in the standards body getting involved in that discussion.
Yeah, I think one of the key things is time to market on this. You know, you've got to get these things developed quickly, and you can't afford 2 or 3 years because, I mean, you know, a couple of years back, who would have heard of ransomware? Or, you know, there's, you know, the threats emerge, you know, week on week, almost day on day, different spins on threats. And I think to sort of just, you know, to take a while building them. So anybody that does get involved in this needs to be able to respond rapidly and not have a process that takes forever. And there's, you know, a couple of them out there where, you know, when you're building a protocol such as the IETF, you have to take time. You have to spend a lot of time considering edge cases and corner cases and what happens and what not. Yeah, when you're doing this, I think there's a lot of these are fairly big problems, and you have to actually deal with the majority of the problem at once.
Yeah, it also has to be an open process, and you have to get feedback from the public, et cetera. So it can be a slow process depending on which route you take, and we need to be able to, as I completely agree with Michael, we have to be able to speed up that time to market.
A different part of the question, though, was, if I understood it correctly, was that there is people who have information, and they need to find some way to provide information to each other and to coordinate their response. And so one of the things we want to think about is what is the best way to do that. And some of these informal organizations in the past, where the carriers cooperated, you know, are a good model. So if you look at the data that's available, held by each different actor in this, we actually have a relatively good set of data. But because it's broken into parts, our knowledge of the problem, our ability to respond isn't as good as it could be. So I think that's where the precedent that we're talking about, we do have some precedents that might be useful to build on. How do you get people to coordinate action based on knowledge that they all possess?
But I mean, we also have to recognize that it's a more complicated ecosystem than the old telecom world, where, you know, a particular phone number, you know, if somehow it's been identified as a bad actor, you know, that phone number really could only be used for that one purpose. Today we have completely legitimate websites that are doing business and doing valuable things in our society that also have been infected and are compromised and are doing some bad things. So it's just, I mean, it's not as simple as it was in the old days. There is a lot of there's more complexity in terms of the risk of harming completely innocent content.
Okay, thank you. Sir.
Yes, Carl Bradley with Harris Corporation. There is some precedence and some lessons learned related to what we're trying to do here. Many years ago, in response to the Advanced Persistent Threat, the DoD implemented the Defense Industrial Base. Part of what the DIB's charter was to do exactly what you're trying to do, take a bunch of disparate organizations who have very different missions, both in the government sector and private sector, and enable them to communicate the threat, their mitigation processes, and come up with, a defense in depth strategy. So I just wanted to throw that out there, that there are some lessons learned. The implementation is not easy because, in effect, what you're doing, you want some level of non-attribution with what's possibly transpired within your own private network, and you want to communicate that securely to one another. And the other piece is I wanted to, this is more addressed to Ari, NIST has made significant strides with the implementation of SCAP, the Secure Content Automation Protocol, and that's one way where a method by which the FCC could enable a resource, whether or not it's posted on a website or something like that, where ISPs or customers could access, again, a tool set to automatically pull vulnerabilities in, mitigate various threats and vulnerabilities and the like.
I mean, thank you very much. I mean, I do think SCAP is a big success story and has not gotten as much attention as it probably needs to, although a lot of the private sector is now actually implementing SCAP, even though it was designed for the government. So but I agree with you. One of the ways we can get faster, you were asking about adaptability before, by raising SCAP, you raise this idea of automating a lot of these solutions, right? And that really, SCAP helps to do that. I think there are a lot of other efforts out there that can help to do that. Not the total solution, but certainly gets us down that path of moving much more quickly.
Sir? Oh, I'm sorry, I didn't see who. Go ahead, sir.
I just had to ask, I'm familiar with the Making Security Measurable and SCAP, and that goes all the way back to the CVE. You said about these success stories. I'm just kind of curious, we've heard about how the antiviruses don't really catch anything. Configuration security protocol lets you know what vulnerabilities, but it doesn't tell you if you're owned or not. What do you do when people are non-compliant? How can a compulsory compliance to a standard is to incent you to do things you're otherwise not incented to do. So you have to comply to the standard. If not, but how do you sanction stuff for people who are non-compliant? In the DoD, we know, ever since eligible receiver, that the vast majority of breaches are due to non-compliance. What is the success in SCAP besides potentially automating the enforcement of? But how can we resolve that enforcement? Because we don't seem very good at enforcing non-compliance sanctions at all in any industry, whether it be for cost or other purposes. Mission first, that kind of stuff that I've seen in the DoD firsthand.
Well, I think that's one of the big problems. So one of the things we'll have to wrestle with as a country is how do we want to enforce better security. And there's some initial, the Australian effort, is a good example of a voluntary effort that seems to be having some traction. And so you want to start with voluntary efforts. You want to start with things that are not regulatory and see how far they get you. In the cases you're talking about, if it's an individual agency, they can do pretty well. They have some enforcement over the people using their network. When you get into these broader situations where you're selling a service, then we're going to have a problem, because you'll find some point, I don't know if it's 10% or 5%, or 1%, where people aren't going to do the right thing. And what I'd like to do is maybe first get there. If we can fix that 80, 90% of the problem, let's fix that. And then we'll worry about the hard part. How do we get the non-compliant to play along? I can figure out how to do that, but it's just politically difficult to,
The 80, 90% was the non-compliant.
I don't think that's right. I think when you look at, I don't.
In this space?
I'm going to put
The CIA put that out, a bunch of stuff, as well as U.S. Secret Service in cooperation with the Verizon Data Breach Report guys. And I've seen it firsthand for years.
I'm going to put the government aside, because I think it's a different set of questions from the private sector in this on this particular question. But I do think there's a lot that can be done in the private sector in terms of just transparency to the problem, right? I mean, that it can incentivize better behavior if we start to show non-compliance, publicize non-compliance, and do a lot more work in that space. I think we can, and we saw it with data breaches one of the biggest drivers to thinking of personal information as something that needs to be secured has been the data breach laws, right? Because simply a transparency law.
The disclosure, compulsory
requirement,
disclosure.
state's disclosure requirement law. So I think that there are several examples, but I think that's probably the one that you can most easily cite as changing and incentivizing good behavior around the way personal information is used. I was just talking to someone yesterday who's a consultant who was telling me that they were doing the computer consultant was talking about a security work with companies, and they were asked, are you going to be dealing with personal information in their insurance forms? Why would that have come up? That would never have come up before the data breach laws, right? But now we're building this cycle of incentives around the holding personal information and what that means and what the security around it is. Your insurance rates are going to go up if you have to deal with personal information. You're not showing that you're securing it. So I think having transparency is not the only answer. Again, as I said, I think this is all a whole bunch of different tools that we're going to need to use to get to the right answers, but transparency helps drive us in that direction of answering the questions on noncompliance.
I mean, it's very hard to comply if you don't know you've got a problem. And there's an awful lot of end users out there who don't know they've got a problem. What are they going to comply to? So, I mean, I think one of the things is education. People have got to know that by being on the internet, they can potentially put themselves in a problematic situation. And then, such as we've done, then you bring the information to them saying you may have a problem. The compliance rate then actually isn't that bad.
I agree. It was more in reaction to the previous comment at the organizational level where things like SCAP get implemented. At the end user level, absolutely, I don't think that'll even never happen or maybe not for another generation or two. I'll allow it.
Okay. One last question, sir.
The panelists have described this as a multifaceted problem, but there's a facet that I haven't heard mentioned, a term that I haven't heard mentioned all day, and its contribution to security problem, and that's operating systems. Are there sensitivities that would tend to discourage your organizations and agencies from advocating and encouraging the development of new, less vulnerable operating systems? It wasn't too long ago that Google announced, I don't think they've shipped it yet, but a Chrome operating system that seems to have some radical means of protecting the computer that it's on. Is this the type of thing that perhaps there may be a role for NIST in advocating or setting standards for this type of development? Now, I know that whatever operating system you have, if it delivers email to the user, you will get an email that claims to be from PayPal that did not come from PayPal. So perhaps we could imagine something that could warn the user that, this really did not come from that source.
I think we did talk about operating systems. You had of course, Ed talking about software engineering, and we talked about the direction technology is moving in, and the fact that within some period of time, less than a decade, probably maybe a decade, the kind of operating systems we worry about now will not be the primary mode people use to connect to the internet. So I think this is a problem that will go away over time. That we will be using different things.
I would just say on that I do think NIST is spending a lot of time on the cloud because of those issues and because of the push there, but also because in the cloud you also have this one of the panelists from IBM on yesterday's panel. Right now there's a cloud workshop at NIST that ran yesterday and today, and it's still going on today. And I think there's another security panel that's on right now. But the first security panel, someone from IBM said an attack in the or an accident in the world we know today is a car accident. An accident in the cloud space is a plane accident, right? You have everyone together. So there's a lot of attention right now on trying to figure out how you set up those rules for cloud providers in ways when you have all that co-hosted information together to do a better job building security in.
And to just pile onto that for 1 second, and then I'm going to not talk anymore. The issue here is that if we had a perfect operating system, and I hope one of the things that's come out of the discussion today in both panels, if we had a perfect operating system, the opponents, especially the APT type opponents, would just figure out some other way around it. So the technology is an important part. It's nice. I like it a lot. But we need to think more about what flexible defense is and what responsibilities are for service providers. Because if we had a perfect operating system, I know that our opponents would find some other avenue in.
I mean, they're already social engineering.
Sure.
Yeah.
Right.
And that's what's driving an awful lot of the stuff. You know, a lot of people are getting socially engineered into situations where they bring the threat onto themselves. And, you know, it doesn't matter how good your operating system is at that point. If someone honestly believes that somebody in Nigeria wants to give them $42 million, there's not a lot you can do. You know, I mean, greed's a great motivator.
Well, you look at the registrars, you look at, kind of the incidents that you've seen, in the last couple of years, whether it be CheckFree or Baidu or Twitter and the like, in terms of domains being taken over, had nothing to do with DNSSEC, and DNSSEC would do nothing for it. They were purely socially engineered.
Yeah, if I could, on the operating system question. Yes, we are in favor of more secure, better operating systems. I think if you look at the major OS vendors, they actually have been doing a considerable amount of work and quite a bit of improvement. They're not perfect. They never will be. No one will. Okay. I'm also aware that the government, there's some cross agency work going on in specifically on operating systems and funding. One of the things is movable code that's being looked at. But even that, okay, as promising as it is today, even that will never be perfect. Okay, we can't. We never will find the perfect solution. We never have in human history, right? There always have been criminals. There always will be. There will always be avenues of attack, and they will exploit them. What we can do is make the best systems we possibly can, and then to be vigilant and be aware that we must always be vigilant, and we must always respond when we can. So, yeah, OS vendors should be doing their part. Perhaps Google Chrome is a better solution. I really don't know, but it is one of the facets. Absolutely.
I mean, if I had one wish from the operating system, it'd be the ability to nuke a machine and not lose the data. Because if there's something that really disincents the end user from doing anything, it's they're scared they're going to lose the little the pictures of Johnny when he was 1, or the family party, so they don't do anything because it's too hard to do it. But if you have a version of whatever it is, Windows 11 came with a button which said nuke and it's going to be fixed in 2 minutes, but your data's still going to be safe, that would be a massive advance.
But it certainly should be noted, sitting in this building, that the FCC's jurisdiction probably doesn't reach the operating system level. So, just answering the question. No. That was not a response to you. That was a response to the broad question.
Yeah. Let me please join me now in thanking panelists that were here today. And we'll be wrapping things up now. Let me thank you all for coming, and thank those of us that you joined us on the webcast. We've heard a lot today. We've listened for 3 hours and engaged for 3 hours on cybersecurity, and we barely scratched the surface. I've been at this or working in detail on this stuff for 6 months or so, and before that, but really intensely for the last 6 months, and I feel like I've barely scratched the surface. So this was very helpful for me. I hope it was for you as well. And please enjoy the rest of your day and have a great weekend.